I'm not sure you.
Hi.
Hi, Camilo.
Hi,
Can you hear me?
Hongwei. Yes, 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 of
Oh,
course. So,
great.
okay. So I think, yes, in 3 minutes, no, we're going to begin. Okay, I have, yes, this
3
thing, no?
minutes.
Yeah. Um, so this is the plan, no? You can present yourself and later you can present me. And I am going to give some words and I'm going
Yeah.
to present the speakers. And I think that's it, no? Every speaker has 45 minutes. Yes. The first one is Sang Wen Han, no? Doctor.
Yeah.
Okay.
Yes.
Okay. Hi, Dr. Sang Wen.
Hi. Good morning. Good morning.
Yes, I'm Camila, I'm the co-chair of the junior members.
Uh,
So yes, but I'm going to be virtually, but Hongwei is there in presence, no?
mm-hmm.
Okay. So yes, let wait a little bit. Yes. So if Hongwei is going to be there, no? Also, yes. Yeah.
Yeah. Can you see me?
Okay. No, but okay.
Uh,
I think you can go
do
to
we
the
start right now?
stage. Yeah. So
Okay. Good morning, everyone. My name is Hong Wei. I'm very proud to be a committee member of the junior member. Yeah. So for in the last 3 years. So now first let our chair, co-chair Camilo to say something about this section. Let's welcome him.
hi everyone. It's a pleasure to be here. This is the first session of our working group, the junior members. This group focuses on topics that are crucial to early career astronomers across the globe. This includes careers, teaching, mobility, well-being, financial security, transparency, and diversity. Junior members represent the majority of active astronomers worldwide, which represent the future on the field, but also provide an invaluable influx of skilled workers to all branches of society. So we're going to have 4 sessions. This one is related with improving scientific writing skills, theory and observation session. The first one is going to, we have, and it's a pleasure for us, the Professor Dr. Sanwen Han, and he's going to tell us about writing a scientific paper. After that, we're going to have the Professor Christopher Tooth, that is going to tell us about the improving writing skills. So welcome, Dr. Sangwen, and the space for you.
Thank you, Camilo, for your introduction. So in this morning, first, please allow me to very briefly introduce Professor Zhang Wenhan. Zhang Wen is a famous astronomer on single star and binary star evolution. He is an academician of the Chinese Academy of Sciences and the current president of Chinese Astronomical Society. He is also an associate editor of the Astronomy and Astrophysics journal. So now let's warmly welcome Professor Zhang Wenhan to give his talk.
Good morning, everyone. It's a great pleasure to be here. And I would like to thank Hong Wei for his introduction. So today I'm going to talk about how to write a paper. Actually, my talk has 6 parts. The first part is why to write a paper. Then what should we do before we write a paper? Then I will tell you about the structure of a paper. Then I will mainly focus on step-by-step writing guide. So I keep it away. And then I will say a few words how to improve a paper. I think Crystal will tell you more about how to improve a paper. So, but for my talk, I will mainly focus on the step-by-step writing guide. And at last, I will say a few words on how to respond to a reference report. I think that's quite important. Why do we write a paper? I mean, there are quite a few reasons for us to write a paper. For some of us, because that's their dream, they want to be scientists, so they want to write a paper. They want to contribute to the field of astronomy. So that's maybe nowadays many of the young people, they have a dream to become a scientist. Another point that maybe for most of us, we want a career. Sometimes we want a degree, a PhD degree, or we want to get a job, and we want to get research funding. We want to get some rewards. So we also want to get the recognition of peers. So I think that maybe there are some other reasons to write a paper. I think that's the major reasons I can think of. Actually, before writing a paper, we need to do some preparations. So normally, I think we need to do a literature search. Actually, for me, when I want to write a paper, because I'm new to this field, I will search ADS or Google Scholar. I will search the most cited papers. Normally, I will read the papers, the top 20 or top 30 most cited papers. And for the first, the most cited paper, it may, because you are new to this field, it may take you some time, sometimes 1 week or a few days to read the paper. But the more you read, the less time you spend. So there is, it's not, say, when I say we read 30 papers, normally only the first 2 or 3 papers take you time. For the others, they are all more or less similar, quite similar. And also you need to read a paper that's referenced in those most cited papers. More or less, those papers are for some the methods, some of the key points. So that's what we need to read. And also, you need to you don't want to know only the papers in your field. You need to know what your paper, I mean, what your field has any other relation, any other context in astrophysics. I think that's also important. You know, what you are doing is not important in your field, but important in other fields. I think that's also important. And also, you can use ADS to check the most recent publications, so you know what the recent advancements. When you do your research, so you need in your mind you say I'm doing research, and after the research I will have a paper published. So normally during your research you need to take notes. You have a notebook, you take everything down in your notebook. So that means when you start to write the paper, you know where your data is, what method you are using. So I think that's important. Also, you need to keep the raw data. Raw data, that's important. So you can always produce figures from your raw data. And also, because when your paper is published, some readers may contact you for your raw data. So raw data are you need to keep. Also, surely for everyone, if you want to write a paper, first you need to check the web page of the journal. There is an author's guide or an instruction how you should write the paper. So, for example, this is for INA, the author's guide. Now let's talk something about the structure of a paper. So, talking about structure of paper, we need to understand what a reader is looking for. Normally, being a reader, you want to know the context of your research, and why you do the research, and what kind of question you can answer from your research. So that's the introduction. And also, if a reader wants to do a work similar to yours, and he or she need to understand your method. So we need to have a section for the method. So there's a step to conduct the study, and also we need a results section. That's what kind of result you have found, and also the most important section, I think, that the discussion, the conclusion. That means how you interpret your result, what the result means. I think that's the most important thing. You are not just to show your result, but the meaning of your result, the contribution your result to astrophysics. So generally, we should for a paper, we should have part like the part of introduction, then observations, calculations, mathematical derivations, result, discussion, and conclusion. But in reality, this is in detail. We should have a title with authors and the affiliation, abstract, keywords, then the introduction of the result, the current conclusions, and also we need acknowledgement, references, appendices. This is more or less the structure of a paper. Now I spend most of the time for a step-by-step writing guide. What is a good paper? So a good paper should be clear. There are no unnecessary detail. Because for many junior people, normally when they write a paper, they write everything they know, every results they have. But that's not a good practice. So you need to avoid unnecessary details. And also, the paper should be simple. I think for most of us, English is not our first language. So it's better to use something simple. So in this case, it can be easily understandable to most of the readers. So please use direct language. The other thing that the paper should be impartial. So for any of your statements, that you should avoid those unproven statements. You should present how and where the data were collected, and how the data supports your conclusion. I think that you should be impartial. And also, the one thing I think that quite important is the paper, the structure should be in a logical order. So the ideas or processes should be pressed in logical order. It's better in your paper you have some subheadings in a logical header. In this case, that will help a reader to understand your paper more easily. And also, a paper, since it's a scientific paper, it needs to be accurate. By accurate, I mean in your language, you should avoid this weak and ambiguous language. So you need to say something precisely. So that's something quite important. Also, you also need to be objective. So for the statements and ideas that should be supported by the evidence. You also, to be objective, that also means you need to acknowledge the work done by other people. So in most of the cases, we will do some work. Not all work are that original. Normally, some pioneers, there are some pioneer work. We need to reference to that kind of work. You see, this is the structure of a paper. But in reality, when we write a paper, we don't follow the order like a title, author affiliation, abstract, introduction. We don't normally follow that order. I think actually this is quite dependent. For most of us, the writing of paper, the order would be something like this. We need to put figures. We needed to have tables, the method, the results. I mean, in most of the cases, we write a paper in the order something like this. This is quite dependent who you are, what normally you are doing. That's, I mean, it's not mandatory. I mean, but for most of us, we do things like this. So in my following talk, I will follow the orders like this. So when we write a paper, first we need to put the figures, and then we need to write method, results, appendices, discussion, conclusion. We do like this. So in my talk, I will show that like this. figures are very important. We often say a figure is worth of thousands of words. I'm not sure, for most of us, when I see a paper, I saw the title, I read the abstract. If I'm interested in the paper, then I will go into the figures. I mean, normally when I check those figures, I know all the stories about the paper. So figures are very important. They are the most efficient ways to present your results. For figures, figures are used to document your data, to make comparisons. So from figures, you know the cause and the effect, and a figure to the story, and the figures are really important. For figures, a figure should be self-explanatory. By self-explanatory, I mean when you read the figure, there is no need for you to go into the text of the article. You just see the figure. You understand what the author means. So I think that's the most important part for a figure. That should be self-explanatory. And also, a figure should have a nice looking. I mean, it should have a very good appearance. For that, if you have some lines, that should not be quite crowded. The label should not be too big or too small. If too small, it's difficult to distinguish. It's too large. I mean, the figure is not not looking. So the symbols should be clear. Sometimes you need some markers or different length tags. Nowadays, it seems lots of junior people, they like to use colors, very colorful. So maybe that's a trend. But I think it's better to keep the figure as simple as possible. If you can use black and white figure to express your ideas, I think keep it black and white. But because for colored, I mean that's okay. But maybe we may see there are some people maybe color blinded. So it's better to keep the figure as simple as possible. If the simple, I think the better. So here I took example. That's a paper written by Xuefei's student. So that paper is greater than wave radiation of double degenerates with extremely low mass Waldorf components. So this figure shows how the double degenerates form, that the formation channel. I think with such a cartoon figure there, it's much easier for a reader to understand how a double Waldorf formed, the carbon alternate Waldorf, extremely low mass Waldorf, how it formed. I think it's the better. I mean, if you check this figure, you can understand the formation channel very quickly. But if you write into text, it will take lots of time. So that's much more comprehensible. And also, during our writing, at the first, he brought a figure like this, and he gave the figure to me. This figure, that's the birth rates of double Waldorfs and the birth rates of semi-detached double Waldorfs. and if from a halo disk, something like this. Then I said this is not good because that's quite crowded, and it takes a reader very long time to understand the figure. Then later, he did something like this. I think this is simpler. So that's for the total rate, the total birth rate of the double white dwarf. That's the total birth rate of the double semi-detached white dwarf. So that's the disk plus bulge. That's for the halo. And this is from the common evaluate channel, so this is much better. But I think this figure can do even better. But I think this figure here is better than this one. And also, I think this figure is quite good. That's quite self. I mean, it can tell a story by itself. That the moderate. That's a moderate of double white dwarfs. So you can see this from Hongwei Girth model, the third line. So you can see very easily. This is from polytropic model. This is from observation. So from this figure, there is no need for you to read the caption, no need to read the text of the article. You can understand the figure exactly. I think a figure should be something like that. And this figure actually I enjoyed it very much. This figure was plotted by Hongwei's student. This is just try to show the entropy profile. For the entropy profile, so they have a HR diagram for the average track of 1.6 solar mass star. So they have some points, say the zero main sequence. I think the maximum radius point, I mean the 1, 2, 3, 4, 5, 6, something like that. So he also labeled the profile of the 1, 2, 3, 4, 5, 6, and also something why that's helium star zero age main sequence, the maximum radius point, the terminal age main sequence, HR diagram, the HD, the Hertzsprung gap. So from this, you can understand this figure very easily. So I think that's quite good. But I think maybe A and B, the label may be too large. I mean, I think we can make the labels here larger, maybe something smaller, and more beautiful. I think, but this figure, I think, from my point was that I like this figure very much. You know, also for the now I talk something about labels. Labels that will give the exact numerical values of the data. So the layout, I think, that's quite crucial. So the layout in the order of entries. So it will be easier to make comparison, and also easier to see the trends of the data. So also that should be self-explanatory. So you just read the table, you know what the table says. There is no need to check the text of the article. So that means we need a very good caption. Every item in the table should be clearly defined, and the unit, the uncertainty should be clearly defined. So actually, this is a paper that's a table I plotted. That's my 98 paper. That's for the formation of double degenerates from from different channels. Because in our model, we have lots of parameters. That for population 1, population 2, you will have stellar wind. So for stellar wind, we have tidally enhanced parameter, because this parameter was invented by Chris. That's a tidally included parameter B. So there we adopt different values, and also the common the Roche overflow efficiency. I mean, what fraction of the mass had been accreted by the gainer, something like this. And these are the birth rates of double degenerates. I mean, that's in our galaxy. The total birth rate, that's 0.03 per year in our galaxy. So for this, we can. So I think it's quite easily to make a comparison. So if we have stellar wind or not, we can see the difference. If we increase the value of parameter B, we can also see the trend. We can also make a very easy comparison for the number of double degenerates among different formation channels. I think a good, and I'm not saying my table is good, but you should make your table as easily understandable as, I mean, you try your best to make your tables to be easily understandable. The next section is about the methods. Methods is how your research were carried out. So that's different for theoretical paper. You need to say something about the code you use, and also you need a brief introduction for the physics and any updates, any kind of parameters. And also for theoretical paper, you also need some assumptions and the inputs and prescriptions, something like that. For observational paper, you need to say which telescope, which equipment you have used, what's the data reduction package you use, and how you have derived the physical parameters, the temperature, abundances, something, orbital period, something like that. So here example appeared that I'm still using that paper as an example. So for here, for observations, we have something like this. The ERM survey, the Gaia data. For the models, we see the population at the parameter space, the galaxy model. I mean, we have all things like this. Then there's the section of the results. So that's what we have found. But normally you only need to present the results that's representative, not all the results you have obtained. So you also need subheadings to keep the result of the same type together, so that makes it easier for a reader to follow. And also, it should be in a logical order. Say, for our paper, we say the result, the number of double degenerates in the galaxy determines the greater wave radiation signals, the foreground noise, the combination of electromagnetic counterparts, or something like this. So that's in a logical order. Then I go the thing about the appendices. By appendices means it's not essential for us to understand the paper, but you can understand it, but this could, because for some of the readers, they are interested in your paper. They may follow your work. So you need to present your raw data. You need to explain how they formally were derived, and you also need some figures, tables, because sometimes you have in the main body of your text, you only show the representative figures, but you may have many other figures that's quite similar. You can put it here. So I think the most difficult part for writing a paper that the discussion. I think this is difficult. It's the most difficult and the most important part. So here I show some tips for the discussion. So in your discussion, you do not. It's not for you to repeat your results, but you need to have a discussion corresponding to your to the results, and also you need to compare your results with the published one. So I think that's necessary. That's a must, and also in your discussion, you should not go beyond what the data could support. And also, at the last, I mean, the discussion should be rooted in the fact, and also, you know, say what kind of questions your research has answered, what kind of your research supports which hypothesis, and is your work consistent with previous research or not? And what's the weakness of your paper? What's the discrepancies? You know, what kind of results that's expected, and also your results. Is there any other interpretation? I mean, usually for one result, you may have a main explanation. You can also explain it in another way. So you need to show that, and also you need to say for the future. What you or other people should do that for further research. See, for our paper, we say the discussion. We say the uncertainty in the process and the influence of the galaxy model and the comparison with observations, comparison with the previous results. I think it's something like this. Now is the conclusion. Conclusion should clearly show how the work advances the field. It's not repetition. It's not a repetition of the abstract. Here I use a demo that's from Hawked. That's a paper published in ANA. So their conclusion say we show for the first time the IR excess of C-phase can be explained by something. Then by a thin shell, by another thin shell. Then the conclusion is the impact of such thin shell of GA, the impact on the period luminosity of C phase. So this needs further investigation. So this is quite clear to show what the results are and what kind of impact on the future research. And then I come to the introduction. Normally we write the introduction at a later stage. So in the introduction, we need to show the subject area. I mean, why we should do the research, why this subject is important. So normally you need to have a balanced review for the subject. So in the introduction, you should understand what kind of solution had been given already, what kind of other problems we need to solve. Something. And also then later, you need to say something about the paper, the purpose of the paper, and the method or the strategy adopted in the paper. So this is also very important. So here I also show use how the paper as an example. In this case, C phase had been the keystone for distance scale determination. So you see, we use C phase to calibrate the type 1A supernovae distance indicator. So C phase are very important, and the recent 1% precision on the Large Marine Cloud distance has led to new determination of Hubble constant. That is a Hubble tension. That shows this is very important. And then he said, envelopes around C phase have been discovered by the long baseline interferometry. So something like that. Then he said the paper aims at building a phase-dependent SED of a sample of C phase. And so that means what he will do for the paper. So this one, I think that's very clearly show why they had done the research and how they do it. And then the abstract. For abstract, now for NA we use structured abstract. I think this kind of abstract can help a reader to easily understand what you have done. So you have a content, aims, method, result, conclusions. But whether you use structured abstract or not, that's the decision is by yourself. But if you have a structured abstract, that's make a reader to take a very little time to understand what you have done in your paper. So here, I mean, I took this from this paper. That paper it shows why structured abstract is better. So that's the original abstract. That's the structure one. You can see here. You see that I also took the example from Hawks. You see that's so for the context, this pattern observation evidence, infrared access of classical C phase are seldom studied and poorly understood. but probably induce systematic on the period luminosity relation. Then the conclusion is that the presence of a thin shell of another gas around surface had to be detected with interferometer operating visible. The impact of such CSE at the shell on the period luminosity relation in the more investigation. So that's quite is very clear. So for a reader, you need to understand text and the conclusion. So method, what the method result. I think that's much easier for a reader to understand. Then the title. I mean, a title is very important. This is the normally whether a reader will read your paper or not. That depends very much on your title. So, the title must be very informative and concise. That's a paper. That's one of my student paper. And at the first, we had many choices of the titles. The hyper-velocity candidates from Gaia DR2, and then analysis of hyper-velocity stars, and refining this selection criteria for hyper-velocity stars. Then later we thought that's not very informative. I mean, that's too general. So later we use something 3 new later type hypervelocity star candidates from Gaia DR2 with a refined selection criteria. Because for hypervelocity candidates, most of the candidates are early type. So we have late type. So keywords and part. So then acknowledgements. So we need to thank people, everything, and also reference. For references, please avoid excessive self-citations. Then how to improve this part? Actually, I think I need to skip it because Chris will talk more about that. And I think the important thing is how to respond to a referee's report. I mean, maybe in the audience, some of you may have been a referee. For a referee, normally a referee is asked to answer the following questions: why the paper should be published? Are the assumptions spelled out clearly? Are the methods described comprehensively? New results adequately emphasize figures, labels, okay. What kind of material should be in appendices? Is this according to IAU rules? Something like that. So normally when you get, because a referee works without any payment, they work free of charge. So a referee is a very precious resources. So when we have that report, we should take it very seriously, because maybe referee is the only person who read your paper thoroughly from the beginning to end. I think so. You should pay respect to your referee report. So first, you need to read the report thoroughly. So you need to understand the key point. What's the key point of the report? That's important. And also, because due to different culture background, maybe in one culture background, this report is okay, but in other cultural backgrounds, the report may be harsh or critical. In this case, you need to stay calm, because the referee is try to make to improve your paper. So, please keep calm. I know that there's something sometimes some people they think very politely. Some referee point out the problem very directly. So that's quite different. And also, you need to organize your response. So you need to thank the referee, and also you need to give a point-by-point response. So you need to use subheadings, and also you need to clearly describe the change you made into the referee report. And also, sometimes the referee is not always right. Sometimes you don't agree with the referee. In this case, you need justifications. So you need to provide a clear and respectful justification for why you believe no changes are necessary. So in your response to the referee report, you need to avoid emotional language. So you need to keep your tone respectful and professional, even if you disagree with the feedback. So I think that is quite important. Sometimes if your response is you show your respect to the referee, then after one or two iterations, it will converge. But sometimes, if your tone is not good, there may be a fighting. So your fighting will take your refereeing process for a much longer time. So you have lots of iterations. Sometimes your paper may get rejected by this referee. Then I need to look for another referee. So also you need to acknowledge your mistake. So also when you make the change, what kind of change you have made, and also in the change, your change to be highlighted. So in the text, so they make a referee to be much easier for referee to know what you have changed. So that's a template, something like this. So I don't have much time. So that's a template, something, and also I think something like this. I send the referee the comment like this. So that's the referee report. That's my answer, or something like that. I think you can plot some figures. I think this is make a referee very easily understand your feedback. And also, I have served for ANA for over 6 years. The editor-in-chief that's Theory Forview. I'm a associate editor. That's we have 14 of them, and also have been the one of the 2 editor-chiefs for the last 6 years. So there are no page charge for data journal. I think that's quite good. So what I see means why I said that it's not advertisement. I have been working in astronomy for the last 40 years, and also have been associate editor or editor-chief for more than 6 years. So I have lots of experiences. So if any of you have any questions, I will try my best to give you an answer. Thank you very much.
Thank you for your talk. So, quick questions from the audience or audience online.
Thank you for that talk. even after having written a lot of papers, I still learn something from listening to advice like this. So I appreciate that very much. Do you have any advice for the younger researchers who they will start to be asked to referee?
Yeah.
And in many cases, and I know I went through this when I was coming up, you may be hesitant to do so in the beginning because you think maybe your knowledge isn't as advanced as it should be. Is there anything you can offer in terms of how reading and writing papers prepares people in principle to be good referees?
Yeah, yeah. I mean, for choosing a referee, for me, normally, in my mind, I choose the senior referee first. But in most cases, those senior referees are very busy. So sometimes they could recommend some of the junior people in their group. For us, I think we need to train those junior people to be a referee. So we have there is a database, records. So who has reviewed how many papers, whether he's good or not, whether he's on time or not. I mean, something I choose. For me, I also, when I see those recommendations, I will check the publication list to see whether he's is peer or not. Sometimes maybe Bill prefers some of the subject. The referee pool is very small. Only a few people do it. So in this case, I have to choose very junior people. Maybe he or she has not got his or her degree yet. I sent her email. I said, if you have anything you want to consult with me, you are welcome. So I will check with that. Yeah, that's something. Yeah.
So, thanks, Chairman, again for his talk. So, so now our next speaker is Professor Christopher Todd, and he's also famous astronomer on stars, everything about stars. He's a John Coach Adam astronomer and a fellow of the Churchill College at the University of Cambridge. He also got many other positions, like the NATO fellow at Leak Observatory, research fellow at Space Telescope Science Institute, and the Royal Society Overseas Fellow at Conklin Observatory, and a joint professor at Monash University. Now let's warmly welcome Professor Todd.
Okay, thank you, Zhongwen. Right, I promised to be done in time for the Kavli lecture at 12 o'clock. Thank you. Yeah, I am going to be telling you a few things about improving writing skills, and I've had to referee a lot of papers. I've had to read a lot of papers written by students. There are some things which I will point out. I'll point out what I consider to be some of the bigger mistakes. But first of all, I mean, Chapman said the reason for writing a paper may be to enhance your career or something like that. I think the main reason for writing a paper is because you want to communicate. You want to tell people what you've done. And the way that people communicate is by telling stories. I think the one really important thing is that your paper tells an engaging story. Tells you right from the start why what you want to do is interesting, why, and then go through what you've done and then tell people how you've actually managed to do what you wanted to do. But try to be engaging right from the start. Zhongwen said he writes the abstract as number 8. I think I would write the abstract first. If you write the abstract is a short piece of work. It tells you exactly what you want to put in the paper. If you've written the abstract, then you don't tend to go off on tangents while you're actually writing the rest of the paper. So you can change it later, but I think if you start with the abstract, you know where you're going. Gentlemen said both these things, write concisely and precisely. I think these are all very important. So a paper is not, it's not a novel. You shouldn't, you don't want to say too much. If you write a review, then perhaps that becomes more like a novel. A paper is a short story. You want to get to the point. You want to get there quickly and clearly. One problem that I see all the time is that sentences become too long and convoluted. You lose track of what's going on. If you know the Hitchhiker's Guide to the Galaxy written by Douglas Adams actually went to my school, and at one point he came and told us how to write well. He said what he does is he writes a short sentence followed by a long sentence followed by a short sentence and keeps going like that. Actually, the short sentences are the clearest, especially if you're not totally fluent in English. You can get mixed up. So don't try to write long sentences. Try to write shorter, clear sentences. Okay, now I'm going to spend the rest of the time then picking up on a few points that I find bothering when I read what people have written. First one, right, in this modern age, we seem to like acronyms, and similarly abbreviations in papers. I think that these often confuse you, especially if you put the paper down and you pick it up a few days later and you've forgotten what the abbreviation means. So this can just be avoided. I think writing things out in the text doesn't take too much space and makes it much easier to understand. So you can use things like AGB for asymptotic giant branch because everybody in the community knows that. And it also takes a while to read out asymptotic giant branch every time you want to do it. But so AGB I think is fine. But if you go to something more in the same field, something more technical, the process of hot bottom burning, which is where hydrogen burning takes place at the bottom of the convective zone, it's not so obvious. So you pick it up in a few days' time and you see HBB and you wonder what it means. So spell it out again. I would just say hot bottom burning. It's much easier to read. Okay, that's my first point. Next one, tenses. Tenses in English are you also use a spell checker. You can see I misspelled occasionally, and it also helps to read what you've written. So make sure you read through what you've done, and maybe not immediately afterwards. I find if I read something immediately after I've written it, I just ignore the mistakes. So read it the next day. So often you'll find that people start using future tense. Something will happen. When you don't actually mean that. You mean future is something that will happen in the future. So there are times when you can actually use a future tense, such as the sun will become a red giant. But if you're making a model of a sun, that won't become a red giant, so your will is wrong. So that should just be a present tense. So try to avoid the unnecessarily using the future tense, or even wrongly using the future tense. Next, yes, mathematics. So I actually teach a lot of mathematics, and getting students to write mathematics properly and in a correct manner is awkward. Mathematical statements are sentences, so they deserve punctuation. Also certain things like the equals symbol. Here, A equals B greater than C, both E equals, and the greater than symbol, there are verbs, because that is greater than. So they should not be used as adjectives. And unfortunately, this is becoming very, very prevalent, I find, in the literature. So if you say something like for objects height greater than 10 meters, that's just wrong, because this greater than symbol is a verb, not an adjective. So try to write words for your adjectives. So either spell it out for objects of height more than 10 meters, that's writing the adjective out properly, or better, just change it so it sounds better for objects taller than 10 meters in this case. Okay, and always make everything precise. So another thing that I find a little bit annoying is the misuse of this asymptotically equal to or similar to symbol. Often again used as an adjective or meaning about or approximately. It's it's just wrong, really. If you're using tech, is approximately equal to can be done with \approx, not this \sim, which has a specific mathematical meaning, which therefore ought to be avoided unless that's what you mean. If you mean there is an asymptotic limit to something in your result, then by all means use it. Or if you're more in pure maths and you're saying something is similar to, in the very strict sense of similar triangles or something like that, again, it's the right thing, but it's not if you mean approximately. Okay, this one is fairly straightforward, and I think most people sort of get it right now. There's by convention, if you're using subscripts or superscripts, and they are constants, or therefore just a description, as in the effective temperature, they should be in Roman text. If they're a variable, and again, this is where you should read it, I meant of the ith star, but it doesn't matter. The if works in the sentence. So it's a variable, so I could be 1, 2, up to 1,000, whatever. Then indeed, that's a variable I, so it should be in the mathematical mode or slanting, italic, whatever you want. Okay. Dimensions. Now, dimensions are very important. Physical quantities have dimensions. They do not. The dimension is part of the quantity as well as the numerical value, and it's meaningless without both. So, simple example: a length 10,000 meters, but it's the same as 10 kilometers. You need both the numerical value and the unit. Functions, like logarithms, take dimensionless arguments. So you must remove the dimensions before applying the function. And one badly misused thing in the astronomical literature is surface gravities, where you'll often see something like just log g equals 5. Well, what does that mean? You need a unit there, and the unit is centimeters per second squared. But not everybody knows that. The first time you read a paper and you see a surface gravity, you don't know what the unit is. So put it in, make it helpful. It's different if you're using different units. And also, this is maybe more from the mathematical point of view, but mathematicians will use log for a natural logarithm, even though physicists will commonly use ln. I just like to put the base there, just to make it absolutely clear what we're doing. That's part of the precision part. Okay, plots. Yeah. Zhemen showed a number of plots which I didn't like because of the way the labels, the axis labels are expressed. Again, just like the logarithm, you're plotting dimensionless quantities here. These numbers are dimensionless. So this is a mass-radius relation for white dwarfs. And so what you're actually plotting is the mass, which has a mass with a dimension, divided by the unit. So you need to divide by the unit there. Conventionally, again, the mass of the sun, the radius of the sun, they are constants these days, defined by the International Astronomical Union. In fact, so they should not be in math mode because they're not variables. That wasn't always the case. People often did use them as variables, so sometimes you'll see them in italic, but formally these days they should be Roman. Okay, more complicated example, and you can see that here this is an old version, so I've used the italic L sun. Now, on the left, there are no numbers. So on the left, it doesn't actually matter. I don't have to be that precise with the units, the dimensions, because there are no numbers, so there's nothing there. So this, in the schematic diagram, all I'm saying is that we're plotting the log of the luminosity. The unit is then just a constant against the log of the effective temperature. On the right-hand side, then I've actually got some real stars, real stellar evolution tracks. So now we've got now we need the numbers, and so what we're plotting there is the logarithm base 10 of the effective temperature divided by kelvins. And similarly, the luminosity divided by the solar luminosity, and then take the logarithm. I haven't put a mass on here. I probably should have done that. Probably should have put at least 0.1 m sum there to tell you that these were masses. These things, of course, you do explain in the caption of the figure, but make sure you do explain everything in the caption of the figure. If you have a line or some points on your figure, then there should be a description of what they are in the caption. Yeah, which can be very awkward. And so which refers to the last thing that it possibly could refer to. So if we take this sentence, dark matter models fit with the data, which confirms the standard model. Most people want to say there that the fact that the models fit with the data confirms the standard model. But that's not what this says, because the which refers to the data, so it's saying that the data confirms the standard model. So the dark matter models fit with data that already confirms the standard model. So it's not what you want to say. Say, unless you're absolutely sure what you're doing when you put a which down, it's better often to just start a new sentence. So you would say, dark matter models fit with the data, then this confirms the standard model, a new sentence. I think that becomes much clearer. And this is an example of where sentences can get far too convoluted, but a simple example. Okay, references. Now, references are proliferating in the literature, and I don't find this helpful at all. I think maybe the last point is the most important. If you're going to refer to something, make sure you have actually read it. If you haven't actually read it, why are you referring to it? Because it isn't important. So, what do references actually do? Well, one thing they do is to put things into historical context. So in your introduction, certainly you want some historical references to say where the problem that you're going to describe originates. The most important thing is that if there is a prerequisite to the work that you've done, something that has been done by somebody else, or even by you and written in another paper, then your reference needs to bring that out. It needs to point the reader to the paper. So in most cases, the reader ought to be reading the references to understand the paper. If there's 300 references, that's not going to happen. And it's often very unclear which references you ought to read. So sometimes you'll have a comment in an introduction that talks about a particular aspect of astronomy, and then there'll be 10 references. And you don't know which one to read. So in that case, maybe two, but start with a historical one and one that you've read that you understand and that puts across exactly what you want to see. If you want to put in more to bring out specific points, then they need extra writing. They need a sentence or at least a few words to say what is in that paper. Why would you want to read that paper in particular rather than the others? Okay. Yes, okay, this one is just another thing that people tend to get wrong. When you give inline references, you have the names of people. So these are people, not the paper, not the physical paper. So you can't say the formula in Taub and Pringle 1992 because it's not in the people. So it's the formula that we write. So another way of putting it would be Taub and Pringle formulated a magnetic dynamo model. So, but just remember that the names that you put there are names of the authors, not a reference, not a physical paper. Okay, right. I think we're nearly there. Mine was a somewhat shorter talk. Okay, so to conclude, right, the most important thing is that you want to communicate. You want to tell a story. So make your story clear from the start. Do that by writing your abstract. Stick to the story while you write the paper, and everything should go well. Read it later. Make sure that you enjoy reading it. If you don't enjoy reading it, no one else is going to enjoy reading it. And once again, concisely and precisely. Don't add unnecessary verbiage. Only include exactly what you need to make your point and to tell your story. Okay. Thank you. Thank you for listening.
Questions? Do we have any questions online? So, Jaron gave a talk about the how and why and how we can write a scientific paper, and Chris introduce how we can further improve our paper. So I have a question. What's the most important thing that we should care to publish a paper, either to a specific journal, I mean, in APJ, ANA, or a monthly notice of the Royal Society? So, yeah.
You can have your pick which journal.
Yeah.
Well, well, Astrophysical Journal I used to avoid simply because it has very large page charges, but now Monthly Notices does as well. I mean, you can ask them, ask the editors. Often they will waive the page charges. So, so we're lucky in astronomy actually that we have a few journals that are well recognized across the world. And so Astrophysical Journal, Astronomical Journal, Monthly Notices, the Royal Astronomical Society, Astronomy and Astrophysics. These are well recognized. So I think submitting to any of those is fine. I think ANA is the only one that will not charge you these days.
Thank you.
Hongwei, I have some questions.
Oh, you have questions?
Yes, can you hear me?
Sorry. Yeah. Camilo?
Yes. So
That's the way.
I would like to listen some of the anecdotes or stories related with the process of to be editor, or also when the review process, no? What was the most difficult case that you had in the past, no? What was this most difficult paper to write?
What is the question, Hongwei? Exactly.
Yeah, I would like
Maybe
to listen about more in personal way. I mean, what was your most difficult paper to write?
Most difficult paper to write.
Yeah.
Probably the first one. It's just it is a matter of getting used to the idea, used to what you want to do, used to telling a story. So the first one I wrote, then I had quite a bit of help from my supervisor and learned a lot of these things right from the start. But yeah, work with your supervisor. I don't know, does Jean-Wen want to?
Okay, thank you.
Good paper you've written.
Okay.
Actually, for me, actually my first paper was written by Peter. I got my silver medal because I got all the result. I give my result to Peter. And the next day, the paper is finished. That's amazing. Then later, I wrote my second paper by myself. It took me a very long time because at that time, because English is not my native language, so it takes me lots of time. Because it's not like this, we have lots of internet tools to improve your paper, to polish your paper. At that time, no such thing. So you have to do that. And also, Chris helped me a lot to polish my paper. That's something. I think for the logic, I think it's okay for me. But for the language, that's it's very difficult for me.
Yeah, everyone has their own story, so we have learned so much. Thank you for your patience. Now, our question.
Thank you. I'm Marcelina. My question is mostly on the equations, and mostly if you have to write it, if you have to italize it or leave it based on if it's a variable or constant. Sometimes it's very difficult to know when you're writing a paper which part of that equation should be italicized and which one should not. And sometimes you also don't know what part of it is a variable or not. So do you have any resources or maybe like a link to something that can keep on reminding us when you're writing the paper, which part of it, or examples of, like you showed there, which part of the sentences could be variables or not. Because I got that comment, like sometimes in my review, I mean, they had to highlight like, oh, this part should be italicized and this part should be left. So it was very difficult to know when exactly to italize and when exactly not to.
So often things are just subscripts describing something, like the effective for the effective temperature, or you may have the radius of a cloud and say R cloud or something like that. Those are clearly constants. They are just words, so they should be Roman. Units are all constants, so typically should be Roman. There's a bit of the problem of possible variable units, such as the mass of the sun, but if you define it as a unit, then it becomes a constant. Okay. So then, it's usually with the subscripts where you get the problem. So if you actually have a set of numbers, R1, R2, R3, R4, and you refer to Ri, then the I is a variable because it represents 1, 2, 3, 4, etc. So that should be italic. So typically you would have this kind of thing in a sum where you were summing things up, perhaps to do some statistics. You would sum up some numbers and divide by a total. So there you have a dummy suffix, the I, which you're summing over. So that's where you would use it. So actually most often your subscripts are constants. So think about it. If you start with that idea, if you start with the fact that it's a constant, and only when you realize that it actually is a variable, then you change it to italic. So perhaps you have, I think of one. So a complicated case may be something where you're talking about magnetic pressure, and you're using as a subscript B, where B is your magnetic field. So your B is actually, it's variable because it's a variable. So your P subscript B should be italic P because the pressure is variable, and the B, the magnetic field, is also variable, so that's also italic. But if you wrote it as P subscript magnetic, the magnetic then is a word and is a constant, so would be Roman. But so start off Roman, and if you realize it is a variable, then change to italic. Does that, hopefully that helps.
Other questions? I also have one more question for the co-authors. For sometime when we discuss with someone about a scientific problem, then maybe we just talk for a few, like half an hour, but the advice from a supervisor or a professor, that's very helpful. But should we list him as a co-author or not? If such thing happens, on some level, I think that's very important for an idea. But sometimes we only spend a little bit of time. So how to balance that? Okay. It's very hard to answer.
Certainly you should acknowledge them. This is the purpose of the acknowledgements. So if you talk to someone and they give you some interesting help, then an acknowledgement is good enough. If they come up with an idea and some new idea, which you then do some work on, maybe they do a little bit, maybe not, but they've come up with an idea, then that's when they maybe should become an author. But just helpful comments. I think an acknowledgement should be good enough. I know that these days people want to put everybody on their paper again, so there are often far too many authors, and you don't know who's actually done the work. So it's not always a good thing to have too many and to be on a paper that you haven't actually done anything.
And also, you want to list someone as a co-author, you need to ask for permission from him or her, if he or she agreed to be a co-author or not. Being a co-author, that means he or she is responsible for the paper. So he or she need to read your paper, do your comments. I mean, that's a lot of work. So, so you need to ask for permission, I think.
Yeah, this is very important.
Actually, that's important, yeah. If you do agree to be a co-author, you need to read the paper.
Yeah. So, any other questions?
Let's say you have like audit results and so on, and you don't know where to start writing, basically. Is there any advice you can give where to start from writing?
So ask yourself, why did you start? Why did you create the results? You must have had something in mind. So that's your motivation. Start there. Then you presumably, if you're writing it up, you found something that's of interest. So there's your abstract almost written. And then just follow through, write the introduction, describing the problem, the methods, results, exactly as Jan said.
So, Camilo, do you have something to comment, Camilo?
Yes, yes. I have a final question related with these new artificial intelligence tools. What do you think is this good to use it when you are writing a paper, for example, in the translate part? I mean, when you are writing the English part, maybe, because there is a controversy about it. No, there are some journals that they said that we can use these artificial intelligence tools, no, like ChatGPT or something else. So what do you think about it? Is you should recommend it to use it or not?
Okay, so this is something that's going to change, I think, radically in the future. It's like in the past we had the internet and we told people not to use the internet to write their papers, but now everybody does. For the moment, artificial intelligence just looks at things and picks out stuff that's already been written. So presumably you're writing something new. So you've got to write something yourself. Otherwise, it's not going to be new. Once you've written it, if English is not your first language, then it does seem to be a very good way of improving the English. Doesn't necessarily make it concise. So once it's written something for you, you should then go and you should certainly read it, you should certainly edit it and put it into your own words, but it can help. So I'm not opposed to using it, but make sure you do add something new yourself.
For that, maybe for ChatGPT or something that maybe is illegal in some countries. I'm not sure. I don't recall.
It is for the moment, but it may change.
Yeah, it may change. Because for that, I tried to use ChatGPT to portray my writing. I think the English is too good to be true. That's something I don't use. Yeah. Because he used lots of words that I never used. I mean, normally people will not use in a paper. Some vocabulary that's I don't know how that's I don't know the word, but I mean the word is not like a scientific paper, but a paper for a poet or something like that.
Okay, so then you have to read what's been written, and you have to you have to change the words back to the words you would have used.
So, if no further questions, let's thank Jamin and Chris again for the talk, and thanks all the attendees to be here, and those who online. Thank you very much. So see you in 1:30 this afternoon. Thank you.
Check, 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 check. Check, 1, 2, 好，1, 2, 1, 2, 1, 2, 1, 2. Check, 1, 2, 1, 2, 1, 2, 1, 2.
Hello, hello.
I guess not. Oh, Camilo?
Hi. Yes, hi Eduardo, how are you?
Hey, good. Good to see you.
Okay,
So we can
great,
hear
great.
you, we can see you. All seems to be fine.
Okay, okay, thank you. Thank you so much, Eduardo.
Thank you.
He's presenting, yes. He's sharing and present. He'll be the first presenter. Camilo, so you're going to share your screen
Okay,
for your
yes.
presentation?
Yes, yes, I'm going to share
And,
my screen.
and you can also start chairing the session, presenting the
Okay.
topic and everything else, right?
Yes, 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 I'm going to.
Okay, cool. So we are here prepared for you.
Okay. Mhm.
Should be now, yeah.
Okay. Oh no. Oh no. Oh, okay. So we're going to begin in, I think, in 2 minutes.
Hello, Camilo. Can you hear me again?
Hi, yes, yes, Eduardo. I'm
Okay,
here.
perfect. I'm just checking if you are going to take off the timing as well.
Oh, yes, yes, because he's. I mean, maybe you can tell me. Let me see. I have the clock here. I can have the time. No,
Yeah, you have 45 minutes, right?
for 5 minutes.
Including
Yes.
including questions.
Questions. Yes, yes.
Okay, cool.
Let's see. Stopwatch. Okay. Um, What do you think, Eduardo? We're going to begin now, or we wait 2 minutes, something?
We have 1, 2, 3, 4, 4 people here. Maybe I don't know if you can wait a couple of minutes just to make sure.
Yes. Yes, I think we can
what-
begin in 5 minutes or less than 3 minutes or something like that.
Yeah, in 2 minutes, 3 minutes, I think.
Okay, 3 minutes.
If that's okay for you guys, of course.
Okay, it's fine. Yeah. Okay. Yes.
Camilo?
Yeah, I
Maybe-
can begin? Yeah.
Yeah, I think that we
Okay.
can then start. So please
Okay.
go on.
Yes. Okay. Hi, everyone. My name is Camilo Delgado Correal. It's a pleasure to be here. I'm the co-chair of the working group junior members. Also, I'm going to give the first talk for today. This is our SOCNOC. Also is Hannah, Stacy, and Upam, Onway, Brianna, Sabine, Jeremy, Stefan, Mustafa. The working group of AEU junior members focus on topics that are crucial to early career astronomers across the globe. These include careers, teaching, mobility, well-being, financial security, transparency, and diversity.
Camilo,
Yes, yeah.
sorry, just one comment. Can you make your full screen?
Okay, yes. Let me see. This is wait, full screen. Yes. Okay. So
Okay, cool. Thank you.
yes. So now you remember represent the majority of active astronomers worldwide, which represent the future of the field, but also providing valuable influx of skilled workers to all branches of society. So I would like to invite you to visit our website, and you can check it there. During the present AU General Assembly, the junior members working group has prepared a schedule that includes the following topics: improving scientific writing skills, learning observations, science diplomacy, mental health management, time management, work-life balance, and public engagement in astronomy, communicating your research to the public. The specific talks include the following topics: writing a scientific paper, improving writing skills, science diplomacy, the transformative potential of networks to support early career researchers with astronomy education, engagement, communication, and culture, exploring astronomy as a tool for enhancing mental health, the role of peer
Sorry,
mentoring.
Camilo.
Yeah.
We cannot see your. Can you do duplicate on your machine? Because we cannot see your. We can only see your image, not your presentation.
Okay, but let me see. How can do that? because I'm sharing, no?
Yes.
But let me. Okay, now, but now you okay? Now you can see it, no? Yes.
No, it's fine. We can do it now. Go.
Okay. Okay. So I was telling about some of the talks, no, that we are going to have from today and tomorrow. So the invitation is that you stay in our talks, and that we are going to talk about these topics now. Also, tomorrow we're going to have a roundtable of all of the astronomy office, the outreach office, the development office, the educational office of AU, and the idea is how to work with the junior members and early career stage astronomers. So this is a picture that we had with all of the. I mean, we are we're doing our last year of as a junior members and in this organized committee. So it was a pleasure to be doing many projects with the other junior members. We were also in Busan, in Korea, in the past General Assembly. We organized some discourse series by different topics relevant for junior members. This is one of our picture of our meeting that regular we had every month. We had some meetings, virtual meetings, and we have some a space that we can discuss. For example, the Slack space, the Twitter, no, also YouTube, the Facebook. So I would like to invite you to stay with us now. Over these 3 years, we have tried to maintain the working group as a connection between the junior members around the world. We see the junior members working group as an opportunity to recognize our cultural diversity and raise the voice of the early career astronomers. This is a platform which we can discuss sometimes difficult topics such as mental health and financial concerns related to career stability that we know that the early career researchers are having that. Okay, so now I'm going to let me see. I need to here now. Okay, I'm going to share again. Now I'm going to talk about the science diplomacy talk. So here is see view and view full screen. Okay, are you watching my presentation now? Are you watching the presentation?
Yes, but your presentation is wrong. You need to be on full screen. Press play.
Now it's better?
Yes.
Okay. So I'm going to begin. See, this is science diplomacy, no? This is my Twitter account, Astro Colombian. So I'm going to begin. We have observed different structure across the universe, no? Galaxies, emerging galaxies, group of galaxy clusters, merging cluster, including our structure, no? So we have, the ingredients, the human body ingredients, all of the chemical elements that are inside of us. Here, this is the origin of the solar system elements. And at the end, we are universe, no? We are observing ourselves. So this is a plot that I would like to show you. This plot compares the different kind of jobs that we can get, no? So you said the part-time jobs, no, percentage, full-time nocturnal faculty, the postdocs, and full-time tenure or tenure track. So you see how the full-time tenure jobs have been decreased across the years. And of course, the postdocs have increased, no? this is our plot that shows the gap between the number of PhD that in states is granted versus the full-time academic positions. So the problem that we have now is that the number of PhD is increasing at some higher rate than the full-time academic positions. In some cases, there is a difference of order of 2, no? So, and it depends of the country, no? I remember there is a paper that is called PhD Factory, and there was the gap for position in US of 100, no? For 100 PhDs, there was a permanent full-time position. And in Colombia, for example, I remember the last time there was a full-time position for a physicist. There were 100 physicists from different fields that applied for the job. So we need to think what is going to be the future for us, no? So this is our plot that shows what happened, no, in the academic and scientist path. So you can see, I mean, we begin, no, in this early career, no? I mean, first there are 53 that they are doing career outside science. There are 47 that is continuing doing science, but in different scenario. So there are 30% that, I mean, they are doing early career research, so they are doing their postdocs, and there are 17% that they go to other places, right, like industry and government. And there are just less than 1% that they become to be a professor, permanent professor. There's around 4% that they become to be a permanent research staff. So this is an important issue. This is different postdoc employment areas outside academia. You can see that there are, for example, you can go after you finish your PhD, and you can do some postdoc, and after that you can go to work in the public sector. For example, you can go to the government, the local government or the national governments. Also, there are, I mean, you can have other kind of jobs. Now you can not academic university roles, training support, management. Also, you can go to the industry. You can go to the, you can be a professional outreach astronomer. So you can work in journalism, in planetariums. You can work in science museum. Also, you can go to the finance part, no? So there are many paths to do after your PhD. And so one of them is to be involved in science diplomacy or science policy careers. So this is an example, for example, that you can do it, no? You can work with the National Academy Police Fellowship, and you can be involved in science communication. Also, you can work with an elected official, government agency. You can work with federal, state. This is the case for the states, but I mean, you can help to improve the science policy in your local government or in the national government. Also in an international context. For example, there is the International Science Council, and you can work there, or giving advice how to improve the science around the world. So I'm going to show you a case. I was a gestor of basic and space science at the Ministry of Science of Technology at the Republic of Colombia after I did my PhD. Okay, before that I was working in the planetarium also, doing some outreach, but I got this position. So I had to work with people from different knowledge, lawyers, economics, or the financials, also other scientists. And our task were develop some new science policy. And because we need this information to create the way to give the funds to the researchers. So we need to have some criteria to give these funds, no? So it's a different type of job, no? We have many meeting groups to decide these science policies. It's a big group. I mean, when you are working in a ministry of some government, I mean, the groups are very, very high. Also, we need to go across the country because we need to listen of the requirements of the scientists across the country. Okay. Also, you need to participate of panels related with the policy, science policy. This is one of the meetings that we had with the Colombian Astronomical Society to discuss how to be involved with the government at that time. And an example of the work, this is called mission-oriented research. So the idea is that we're going to create a science policy based on missions. So this was the framework for defining missions. So there was the government plan. Also, there was a document made by some scientists, and there are other documents that this is the transformation according to the National Development Plan. Also, this is a public policies in which the science ministry, the Minister of Science is involved. So we need to join of these documents to can create what are going to be our plan. So there was some missions. In this case, I mean, there was the economy, natural ecosystems. Also, there was the how to get the right food, for example, also the sustainable related and health and social welfare. And there was a program science for peace and citizenship. And the basic and space science in this case were an instrument to could move these missions. No? So other case study is the June Academy of Colombia. So this is, I'm part of this academy. And this academy is part of the International Science Council. So I had the opportunity to stay in a meeting in Panama that we met with other science academy in Latin America. And I said that as a scientific group, we should collaborate to address the challenge of our generation, including employment and other complex social situations that impact our region. Our collective efforts can contribute to create a better scientific ecosystem, providing improved opportunity for the new generation of scientists. So when you are working in science diplomacy, you can also go to the person that take the decision that after that the decisions, the science going to moving on. So this is important to be involved in these activities. So we had some meetings with the International Science Council, and we had some had a working group. So we defined the science policy for Latin America. I mean, we're going to have our advice for all the governments. And also we had other dialogue that it was in Santiago, And in this picture, they are the representative of all of the young academies in Latin America. And we were discussed how to improve our condition as a scientist in Latin America from different fields. Also, we were talking about how, as a young academics, we can improve the science. So we need to promote working groups in knowledge exchange, interdisciplinary research, innovation and development, mentorship and support, in science policy. And also, we need to promote the research incubators in science institutions and universities, because these research incubators become to be a bridge between senior and junior researchers. So this is something that is happening now in the Geographic Institute of Colombia. It's called IGAC, that I'm working also. And we're doing this research incubator, because it's usually that in some universities you can get these research incubators, but in the national institutes could be interesting also the process. So this is other example, science diplomacy, this jury member group. We would like to build a network of early career research, organize conference to exchange experience, promote research industry. There was all the co-chair from 2021 to 2024. Now we're finishing our process. It was really a great experience. I told you before, no, all of the activities that we did. Also, there was some screenshot from the past General Assembly, but it was in Busan. So we had there also other talks. Also was in presence and virtually, like now. And we had this space. There was a Discord series that it was a virtual platform. So it was very interesting to participate of this activity. Also, this opportunity, I mean, that this is a picture that we had one of the executive committee, no, and well, for me it was very interesting to participate here. I mean, because it's very important to listen the young voices, no. And I think this is all the things that I want to tell you. So thanks for your attention. Yeah. So now you have questions or?
Are there questions to Camilo? Anyone? Camilo, I do actually have a question. Is there any connection between the junior members group and the Office of Young Astronomers? Or do you intend to have anything, is there any overlap, anything that can collaborate, any connection between these two groups?
Yes, a good question. There are some members that are included in the both, no, in the both groups. I remember that for the past General Assembly, we tried to organize the Young Astronomer Lunch session, but I mean, there is not as much activities. I think this is a good idea to be involved more, join activities. So yes, it's something that we need to do. I think we didn't get the opportunity to do it. No? So we hope to do that. I think the new generation of the OC members are going to do that. I think it's a good idea to approach the young academy. No?
Okay, thank you, Camilo. I think we have a question from an online participant.
Yeah.
Let's see.
Yes. Can you hear me?
Yes, yes, yes.
Hi, Camilo.
Hi, Zach.
Nice to meet you in person. I've been reading a lot about you. Well, this is a very interesting topic, and I just have I have several questions. One is related to the statistics you show because I saw the statistics in the sources. It say 2014, so I
Yes.
don't know if it's already 10 years. If something has changed in these 10 years,
Yeah.
because COVID or I don't know, the rising of AI or something. Actually, when I finished my PhD, which is actually in this period of time, I faced unemployment, and I was not the only one. So I think there was a big COVID situation with jobs in everywhere. I guess astronomy was not the exception. So I wonder if there are new statistics. And well, I don't know. Do you want to answer, or do I continue with the questions? Or
Yes. I mean, the short answer is that I don't know. I mean, I I think this is interesting to do the research. I mean, in these topics also you can write a papers. This is something that sometimes, I mean, we have our PhD in some specific astronomy topic now. But also when you are doing science diplomacy, you can also write, I mean, you can do research doing that. And this is an excellent example of that. So, I mean, I think, I don't know exactly if there is an statistic related with how is this academic, no professional activity of astronomers after COVID, no, how was reflected. But I think I can, I can looking for, and maybe I can send you an email and I can explain a little bit more. I think this is
that would be nice.
should be, yeah.
And the other question is, when you talk about early career astronomers, what we are expecting. So it's like if you are in your 40s, then you are not early career, or if you did your PhD at your 30s. So what is early career?
Yes, it's usually, I mean, the period after your PhD and 6 years after that, something like that. No, I mean, it's before 40s around it. No, I mean, it depends of each
yes.
research, but it's usually, for example, for junior members.
So let's make it focus. So for the junior members for this commission, what do you consider younger career?
Younger career is you stay in the period between when you finish your PhD until 6 years after your PhD.
6 years.
6 years, yeah.
Okay, but what happened if during these 6 years you are, let's say, you had a surgery, or you have your baby, or you got sick and you didn't work for, let's say, 2 years, 3 years? Is this still considered this period of time, for example?
No, this is something that is kind of flexible. I think it's depend of each case. And nowadays, I mean, you are right. I mean, that, for example, in this case, that you need to stay, take care of the babies. No, I mean, you need to more time. So
any reason, yeah.
The metrics or different reason. Yes, the metric has been, the metrics are changing also, because when you are going to apply for some fellowship, they ask for that. So they are saying, okay, you said maybe there was some situation with you and you can explain the proposal, because at the end it's related with the funds. But this is very important to have these statistics, these metrics to explain the situation. And also because there is not a permanent position for everyone. I mean, this is something that is happening, and we need to find other path careers. And as a PhD, we have the skills to involve in different kind of jobs that, I mean, we can go to industry, we can go to the government doing these science policies, we can go to outreach, we can work in planetarium, for example, another science museum, we can work also in teaching, that is very important. And of course, we can get the permanent position and do research or some research assistant position or something like that. Yeah.
Yeah, I'm totally agree with you. I'm doing something else actually. I'm a project manager in something different, related in science, but not focusing astronomy. I'm still doing astronomy as in my free time. But I think there is still this how to say, a stigma in our community. And I think people have this stigma because we are still having this romantic idea of science, that everyone can be a professor, that we can just need to work very hard. That is not true. And people in power positions still don't want to tell the truth, right? They are still believing that if you work hard, you will get it. And it's not true. There are many factors that are taking part of who will take or who will have the chance to have a permanent position. And it doesn't matter how much you work and how clever you are. There are many, many factors. And people is not telling the truth. So I think something that maybe these junior members can push in a little bit is to break the stigma, tell the truth, and yeah, encourage the people, the older people, to also tell the truth and also try to work harder for get more positions. Because I mean, I don't know people in the audience of if you has meet professors, but I have met professors. They are very happy to having infinite postdocs and never work for permanent positions. Say they don't want to do it because it's very cheap. So I have hear people like, why I should to want to fight for permanent positions in my group if I can have for free or almost for free postdocs everywhere. So every year I have a new postdoc every 2-3 years, so I don't have to worry for the contracts for permanent positions. So the people is happy to having us in these infinite postdoc positions. So how we will encourage these discussions with them, because they know and they don't want to talk about it.
Yes, yes, there are these academic situations that I call it. And it's true, I agree. I mean, also there is no permanent position. So this is one of the problems. I mean, there is not. I mean, there is a moment that the number of PhD are increasing, no? And there is not an offers that, I mean, the same offers for permanent position are increasing. So for this reason, and also for interest, I mean, I know some researchers, I mean, they like to do outreach activities. And it's very important that, I mean, we can also work in planetariums. I mean, I was always asking for that if we have a planetarium for each stadium in each city, I mean, it's going to be incredible for our culture, no? For our astronomy culture. So in this case, if we got these new places to work, we're going to be a more diversity path career for astronomers, no?
But I see it's really hard for like only junior members to do that. This is a discussion that should be with more.
I tried,
right?
Yes, I understand. Yes, actually, when there was this executive committee, I say that with all of the senior professors. I said
And what was the answer?
no.
This is not science. We don't have time for that. We need to focus
No,
on scientific research.
actually, they said that I was right, but I mean, it was just it. No, was okay. We understand the situation of junior members and the early career stage, but I mean, I didn't receive a concrete answer. I mean, this is something that we need to do it. This was the reason that in these junior member sessions, you can see that we're talking about different issues that we never talk in academia. I mean, mental health, the outreach, I mean, the importance to do outreach, all this science diplomacy, how to build networks that are very important. The idea is that for the new generation of the union members can raise the voice to the senior researchers. I also did the exercise with the Science Academy, and I said that, but they know that. I mean, I
Yeah, it's
know that
what I'm telling you.
the
Everyone knows
seniors
that
know that, yes.
and don't want to talk about it.
Yes, I think we need to move. I mean, we need to go in a higher position. I mean, we need to go to the politicians. No, we need to go at this stage to increase the funds for science, because one of the problems that we have now is that the funds to investment in science is decreasing across the time. So for this reason, there is no chance that it was before. So this is something that we need to do. We need to talk with the people that takes the decision. Said, okay, we need more funds to do different parts of science. That is very important. So yes, Zach I agree with you.
Maybe
I
we
think
can
are
work more
this-
in get more statistics. Maybe that
Yes.
would be the way to show them, like, look
Yeah.
how many people is how many people are, how many situations, and also to, I know, like, directors in this organization will not have the power. They need to go with the governments. They need to go with higher positions, of course, but they are the voices. So that's the main role. They are the voices, and they need to tell the truth. And maybe, I don't know. I know, I understand politics is like always be polite, always be positive, but as we are the people that always complain about how bad management are in politics decisions, and how systems need to change, we don't want to change, right? We are not being this example of system changing.
And there is something that is important, that we need to learn other skills. Because
Yeah.
when you go out the academia, I mean, you need to learn how to talk to a public
Yeah.
that is not scientist, for example, and give your idea, or write
Yes.
in the way that the other people can understand you. And this is skills that you need to improve, that sometimes we never receive some training during the academia path.
But I
So
think this is related with the stigma that you are in science, you are supposed to be like super clever and only focus in talking with people like you. So this is still the stigma. I know when I was a student, I guess you suffer. Anyone that is happy to do more than science is always with this big stigma in your face, like you are not a real scientist, that you are not taking astronomy as it should be. So this is the stigma that we also need to break, and the junior members should be more active with younger generations and not the oldest because they are, I mean, when we were younger, we believed that we would be professors because we see these people, but now they see us, like, what is the real part of science, to be a scientist, and you can be more than just working in papers. Right?
yes, this is important, and we need to looking for the space and increase the number of space that we can talk in this way. It was the reason that I was personally promote this session in this way. That we had this different spaces to talk, because never you are going to have a space to talk about science diplomacy or outreach. No, I mean, and now I think the situation is improving. For example, you can see the astronomy office. I mean, the outreach office, the educational office, the astronomy for
It's
development
increasing, of course.
office are increasing and are involved many researchers. I mean, they also and they are creating this bridge between astronomers and not astronomers to build projects. I think the situation has been changed I hope that there are some hope in the future, but we need to work on that. We need to work on that. I think this is very important to increase the papers. I mean, we need to write the documents related to all of the new statistics. I think this idea to analyze the pre-COVID, COVID, and post-COVID situation should be very interesting. I mean, I mean, you wanna join? We can write a paper. Or
Yeah, sure. Yeah, very interesting. I unfortunately I missed the election, so for be part of the committee this year, I think.
Okay, it's important. There was you can send it. You are a junior member.
Yes, I'm a junior member.
I think, I mean, I don't know if the link is open, but please write me an email.
Okay, I will write you an email. Yeah.
Or I am in LinkedIn, like
yes,
my
okay,
name,
I will look
Camilo
for
Delgado Correal. So please, and we can talk about many issues.
Yeah, sure. Thank you for
No, thank you to you. One of the issues that I discovered is that you can do research in all of these topics.
Yes.
I mean, it's not in academia. You can do also research in knowledge. You can do research in teaching. You can do research in industry. I mean, I call it applied astronomy. When you are going to industry or you are applying astronomy, I mean, the techniques that you are doing. Actually, nowadays I'm working in a geographic institute of the country and doing analyzing the satellite images. But before doing my PhD, I was analyzing the whole space telescope images. So was remote sensing. So I think we need to be creative and we need to create this new way to be the astronomers of the 21st century. This is part of our task and teach the new generations. And of course, we need to work harder because we need to convince people with the data, with the things. But I think we can do it. This is part of the business, no?
Yeah, no, this is important that we are in more areas because then we are increasing the how to say the fame of our qualities, right? For example, I'm working in data management, and astronomers are always like superstars in data management because they have a very huge fame of how good we manage data. So, for example, and that was something that I never knew, and I'm discovered this new topic, and I see that as we have very good data management in the data management community, we have this big fame. So, but we can do the same in many other fields, of course, like in programming or data analysis, for example. So image analysis, we are experts analyzing images and calibrating and make science from images because this is the only laboratory things that we have, right? Images. So yeah, definitely we need to be in more fields to show our qualities. And yeah, I'm very happy that you are doing this. And definitely we need more voices, of course, more
and something to finish this session, because now we're going to begin the other session, is that always we are going to be a scientist. I mean, if you go to different paths, different academy, always you can be involved in science projects. For example, I'm working now with this applied astronomy as a job, no? But I am advising, co-advising a PhD thesis in the National University of the country, and we already published some papers. So you are going to always, you have the skills to do that. So the point is that for professional, I mean, you need to get a job, and in some moment something could be permanent. So we need to diversify the job career path. I think this is the message. It's not just academia. We have other kind of jobs. And it's very important as a scientist, we work with the governments. We need to give the advice to the governments because they are take the decision to give the funds for us. So if we are not involved in how they are taking their decisions, I mean, we have some situation there. I mean, we're not going to receive the fund that we need because they never know about it. I mean, it's incredible. We need more scientists doing science policy, and also some scientists that could be politicians are very important because the scientist knows what is the requirement to do science. So this is important also. Okay, so thank you, Zach. Yeah, it was.
Yes,
okay.
Zach.
Okay, and thank you, everyone. And now I would like to introduce our second speaker for today. So it's Dr. Annika Miller-Rushin. Hi.
Hello. Oh, that was loud.
Hello. So
Hi, can you hear me?
Yes, perfect. So hi, I can see you now. So go ahead with your talk.
Great. Well, thank you for yours. It was wonderful to hear what you're doing. As he said, my name is Dr. Annika Miller-Rushing. I'm the STEM Education Research Associate for Associated Universities, Inc. And I'm going to be talking about one of our projects that we work on, which is called AstroExcel. And this project I work closely with because I'm in charge of the research and the evaluation for it. But it's also, I'm going to focus on what is AstroExcel and what we've set up, but also then talking about the specific role of the early career researchers within this program. So instead of, which we heard earlier in the first talk was much broader about how early career researchers and junior members and sort of the state of that, I'm going to talk about a very specific project that is trying to utilize early career researchers to really leverage the research that's happening. So the talk is on transformative potential of networks to support early career researchers within astronomy, education, engagement, community, and culture. And I'll talk a little bit more about what I mean by all of those. So what are we going to talk about today? First, what is AstroExcel, so you know about the project and how it fits in to these topics. Leveraging networks, what do I mean by that, and early career researchers. What are some findings and learnings that we have so far, and where is AstroExcel going? So first of all, I always like to take a moment when I start any talk to remind all of you who are here and online with us that you all are part of educating and communicating about astronomy. Even if you are not specifically doing education or engagement or outreach and you are just super focused on some topic within astronomy research, you are talking to community members, you're talking to your family, you're talking to people about astronomy. And so that really puts you in a role of being a engagement person, an educator about astronomy, and you are helping to make others within your community, your families, your friends, whoever you're talking to, what they think about astronomy. And so you all have a role of thinking about connecting astronomy to our communities and what that means. And so at AstroExcel, what is AstroExcel? It's a project I work on. But our focus for AstroExcel is within these contexts, really, where the people that are really focused in AstroExcel are not just the people who are working on something in astronomy that they're researching. We do have people who are doing that, but also part of their job and part of their mission that they feel very aligned with is to connect that to education, engagement, community, and culture. So in the very, very center of that circular diagram that I show, AstroExcel is really committed to breaking down research to practice silos. So one of the things that really brought everyone together for AstroExcel is thinking about how do we take the people who are super focused on research side of astronomy and the people who are really focused on the education side of astronomy and who are doing the more applied work. Oh, sorry, it's not standing in the right spot. If we think about the people that are thinking about the applied nature of that astronomy and the people who are doing the straight research of that astronomy. How do we help each other, those two groups, talk to each other more effectively so that they can both learn from each other? Because as we know, people who are working in straight research can really be helped by their research questions and get those their findings out if they have better connections to the applied practitioners, teachers, those sort of people. The teachers and the practitioners and the applied really need to be talking more directly to the researchers and knowing what the research is. So that's the really core of AstroExcel. And then if we keep going out, the very focus of that is on how do we break down research to practice silos within engagement, education, communication, and culture. And then we are doing that working within networks of networks, meaning it is all the people that are part of AstroExcel are bringing with them, and they are representing a network or networks. And then we are working to bring all those networks together to do more work. And the very basic is that we all want more astronomy for everybody. Is that our overarching goal is to really have more people be engaging with astronomy, and how can we do that? So in AstroExcel, what is AstroExcel? Well, first of all, it's a 3-year, $1.6 million program run by funded by the NSF. It's from 2023 to 2026, so we are in year 1 of this program. It was started, the grant was put together by a group at Associated Universities, Inc. And so they are the ones who are doing the project management, the evaluation, the management of that project. The goal is to use network of networks to increase research capacity and break down those research to practice silos across astronomy, education, engagement, communication, and culture. How we're doing that is to accelerate research. We want to grow relationships between and among researchers and practitioners. And we want to build additional human capacity and infrastructure needed to support an international network of networks. So what are the numbers of AstroExcel? First of all, there's about, right at this point, 40 people within AstroExcel who are really AstroExcel members who are getting supported by AstroExcel. The only support that they get is to attend a summit once a year. They then work, depending on what group they're in, either biweekly or or monthly, remotely. But those 40 people are supported to come to the summit once a year, and they're from 21 countries, so they're from everywhere, which is wonderful. And each of them represent, they are bringing together at least 24 networks from all over the world. So we have a yearly summit, which our first one just happened a few days ago, right before the IAU GA, which was a really wonderful time. And then we have bi-weekly Zoom meetings. And so who are these representatives? So as you can tell, I think this picture that I have up here was actually taken along that wall. We were in this room for 3 days before the IAU GA. It was really fun. But these are the people that were able to come to represent all these different networks. In this picture, there are 6 mentors who are part of AstroExcel. And by mentors, we mean people that are leading what we have many cohorts. So within this group, we can't all do projects all together. There's just too many of us. So what we've done is create mini cohorts where there's 1 to 2 early career researchers partnered up with 2 to 3 to 4 associates, meaning the people who are working on more of the applied practitioner end. And they are led by at least 1 or 2 mentors. And mentors are people who have been working in the field for a number of years, have some experience, have some connections, and are bringing with them also a lot of network connections. So we have 6 mentors. We have 12 associates. Again, associates are people that are generally working a little bit more on the applied side. These are teachers, engagement people, outreach professionals. We have 8 early career researchers. These people are ones who have, within the last 6 years, finished their PhD and are working on much more of the research side. And there's 8 of those. And then the core organizing group, we have 10 of those people who they are representing networks from all over the world, and they are really running the strategic plan and how does this actually work. And a council is kind of, we can think of it as kind of the board. There are 13 members of those. So if you put them all together, all representatives are working collaboratively to break down the research to practice silos across our focus areas. And I would like to point out that for each of these, associates, researchers, all these roles, we put out the call across our networks to ask who would like to be part of this. And we got over 150 applicants for each associates and the early career researchers. So there's obviously a pretty large need to bring these groups together and to have these conversations at a deeper level. And people really were clamoring to be part of these conversations. And unfortunately, we can't fund people to be part of AstroExcel at the numbers that they applied at. So we've done some work to try to have those conversations outside of the AstroExcel network, but we can talk more about that if you're interested. So what are our focus areas within AstroExcel? Well, we talk a lot about weaving across our focus areas. First of all, our big 4 topics are, like I've said, education, meaning, and what we mean by that is a little bit more along formal education lines. Generally, we think of this as K to 16 and much kind of more formal classroom settings. Engagement, meaning informal or practitioner settings, informal learning spaces, all the spaces in our communities that we learn that are outside of traditional classrooms, which are numerous. Communication, all the ways that we communicate about these different areas, all kinds. So we have people that are working who have created children's books. We have people who are working as newspaper author, working in newspapers and print media. We have people who work on communication broadly in different areas. And culture. So what does that look like? So we have people that are working on the history of astronomy in different areas, different ways of thinking about that. We also have somebody who's working on a project where that's called PopScopes, where they actually pop up different astronomy sites. They take telescopes and they just put them on the street in very urban areas. And actually that project has gone now, an artist happened to come across one of these PopScopes events. They were so intrigued, they actually are now working with PopScopes to turn guns actually into telescopes. And it's using a sort of an artist effort to try to bring awareness to the gun issue, especially in the United States, but also how can we connect that to astronomy and thinking beyond ourselves. So that's what we mean by culture. And when we think about the weaving across all these focus areas, we are, in all of these, we're thinking about interdisciplinarity. So it is not just one content area. We're really thinking about diversity, equity, and inclusion. Accessibility for all members, bridging research and practice, values and beliefs, and leveraging and building networks. So all of these ideas are all really threaded together. So if you work in a K-12 classroom, there's really no way that you can only think about your K-12 classroom. You are also engaged in engagement and communication and culture. So all these are woven together, but we all also have our own particular focus areas and how we do this work. So all focus areas are deeply connected and interwoven. So why build networks of networks in astronomy? Why not just have every person represent themselves and not really worry about the networks that they then bring to this? Why are we thinking about building not just a network, but networks of networks? And it's because understanding networked nature of astronomy is really important. Analyzing networks and networks, which we often call NONs, you'll hear me maybe say that, can provide insights into collaboration, knowledge diffusion, and complex system dynamics. If we think about building networks of networks, we can also foster more diversity, equity, and inclusion, which is one of our goals. And studying network of network structures and dynamics can inform initiatives to increase diversity, equity, and inclusion within astronomy networks. We also want to accelerate research and discoveries. It's really one of these goals is to accelerate research and leverage that. So we want to, by using networks of networks, we can identify influential nodes and collaboration opportunities within NONs can accelerate research breakthroughs and new astronomical discoveries. The more somebody knows about all the different networks that are out there and all the work that's happening within them, the more opportunities we have for really accelerating research and discoveries. Also, we can enhance public engagement and outreach more effectively if we are working within networks of networks by mapping and researching networks of networks. Different ways of doing that. I primarily am using social network analysis for this project, but there's lots of ways to do that. We can improve strategies for effective science communication and astronomy-related public engagement efforts. So the bottom line is really that studying networks of networks in astronomy can support AstroExcel's goals of enhancing education, engagement, communication, and culture within the field. So why today am I talking about early career researchers within a network of networks? What's their role, what's their importance, and how can we leverage that? So early career researchers, as the previous speaker talked about, are usually people that have finished their PhD no more than about 6 or 7 years ago. And they are our largest and most diverse cohort of scientists right now. They have a vested interest to improve the system they are inheriting, or have inherited, but very recently inherited. Generally, the data on them is that they're more open and optimistic and feel like they're put in a position to make changes to the system that they're working in, or hopeful to be able to do that. And they often have newest techniques and can work with senior scientists to implement those new ideas. So when you're really connecting the early career researchers with the more established scientists, you can get some really interesting, innovative work potential there because you have the newer techniques as well as the more established how to actually make that work. So we want to recognize the early career research expertise and amplify their efforts to improve science with supportive mentorship, which is why within AstroExcel, we've made these mini cohorts, like I said earlier, where we kind of partner a mentor, 1 or 2 mentors, 1 or 2 early career researchers, and then 2 to 3 associates, so that they can all work together to breaking down those research to practice silos. And I'd read Kent et al. In 2022 put out a really interesting paper, if you haven't read it yet, on the value and sort of what do we mean by ECRs, what is the research on ECRs, and here's a quote from that paper. So ECRs are important stakeholders that are effectively working to catalyze systemic change in research practice and culture. Future efforts should focus on incentivizing and rewarding systemic efforts to improve science culture and practice. This includes providing protected time and faculty positions for individuals working in these areas, kind of a topic we just heard about being talked about, amplifying ECR voices and meaningfully incorporating ECR into decision-making structures, which is what AstroExcel is really trying to do. ECRs working on improving science in communities or countries with limited research funding should be supported by organizations with access to greater resources to improve science for all. And that is one of the reasons why AstroExcel is really a worldwide network of networks. We're trying to link everybody and make sure these voices can be heard across the globe. So how this work works, how are we doing this, and what is our focus around to get this done? So my role within AstroExcel is really focused on the research and the evaluation of AstroExcel. It's evaluation research across AstroExcel is multi-layered in that we're working with AstroExcel members on research that they want to do. We're also working on AstroExcel on the network of network growth itself. So I actually research the network members as they are research participants as well. And we are also working with AstroExcel members to really amplify the research that they're doing in other spaces as well. So my primary objective when I think about AstroExcel research is to really elicit feedback from members about their experience with AstroExcel networks of networks and how do we build these networks more generally so that we can leverage them in future ways. I also have other objectives. We're trying to understand network of networks and how do we use them to accelerate research, especially across education and sharing of resources related to astronomy, education, outreach, communication, and culture. And our interventions that we're looking at are will describe and facilitate the construction of a collaborative infrastructure, a network of networks of astronomy-related organizations and institutes. And some research principles that we follow to do this work, we found, because remember I showed you that weaving together of techniques in our research focus areas earlier and how we do this work. So one of our principles that we follow across our research, whether it's research on AstroExcel or for AstroExcel or leveraging AstroExcel, is really focusing on decolonizing principles. So we really posit indigenous knowledge as part of our research principles. We can talk about different ways we're doing that, but we're using care data management principles. NSF has some interesting data management protocols as well. We're using a type of work called collaboration with integrity, which, if you don't know about the Indigenous Education Institute, they're a really interesting organization that is trying to work across Indigenous knowledge spaces to do, and they have a technique called collaboration with integrity. We're also have some of the example research methods that is really fun. Part of the fun of my job is that I get to use a lot of different methods depending on what the research question is, depending on what the project is. So right now, a lot of time is being spent on social network analysis of the network itself, but we also have a lot of participatory action research project going on with some related projects. I also use grounded theory, discourse analysis, narrative analysis, all kinds of ways of looking at these questions in ways that can be helpful either for AstroExcel or to leverage AstroExcel. If you're interested in example research questions, I have some listed here. So one of our first ones was, what does the current literature tell us about the nature and typology and effectiveness of networks? And how can these learnings be leveraged to increase research and the application of this research within our focus areas? And I'll explain that in a second. Another research question is, how does a network structure with thinking about folding and functionality relate to how partners leverage the network? So belongingness, values, et cetera. And we're just starting to collect some data on that. So I don't have great findings on that yet, but we're starting to collect data on that. And what are current affordances and constraints concerning the areas of knowledge and communication ecosystem across a specific area of UAP, so unidentified anomalous phenomenon? One of the things that's really cool about AstroExcel is that there's, within all these mini cohorts, there's focus areas that they're really interested in doing more work on. And one of the focus areas was a UAP workshop on unidentified anomalous phenomenon. And then we were able to research that workshop and get some really cool data on that, on how do we communicate about these interesting topics. So we're researching the formation of AstroExcel while simultaneously adding to the body of literature on networks of networks and research to practice, those research to practice and practice to research connections within astronomy. So some other research and evaluation outputs, if you're interested. One, there's always outside evaluation. So not only am I doing this work, we also work with other outside evaluators to make sure that we're doing what we say we're supposed to be doing, right? Like we said we were going to do something, we got money to do it, make sure we're actually doing that. So we always have outside evaluation happening. Then I'm in charge more of the research about AstroExcel. So those are projects led by AUI that are really talking to the body of literature on networks of networks, ECRs, research to practice and practice to research, et cetera. And then each of these mini cohort groups, so there's 4 mini cohort groups, obviously 4 focus areas, and they are all doing different projects, and that they are working with myself and others to make sure the research and evaluation on those are also happening. So some example projects that are starting to percolate, remember this is only year 1, so these are still in some nascent stages, some are a little bit further along, but for example, the education mini cohort group is really still determined, but considering a criteria of ways to evaluate astronomy education resources that cut across that research to practice and practice to research silos. So how do we even evaluate what's out there? There's lots out there, but can we create some sort of criteria to help people be able to find their way to that material easier? For example, the engagement mini cohort is considering projects like creating a practitioner-oriented one-page handout on best research-based resources. Because again, there's lots of resources, but how do we sort of point people to that in the most effective way? A communication mini cohort is working on things like partnering with animation experts to help create a more indigenous-inspired and connected planetarium show. And I described what the culture mini cohort group was doing with the pop scopes and turning guns into telescopes. So one of the findings that I can talk about that we have, that we've started to share and that did some research on, one example project that has come from this is thinking about a literature review on social network analysis on networks of networks, but a networks of network within astronomy. So we narrowed the focus of this literature review to thinking about just in astronomy, what do we know about networks of networks, and how can we learn from that so that when we go forward, we can be more effective. And what we found was that here's some linkages that we can just show. There were 80 papers in this literature review. I can share it with you if you're interested in. It's not, it's been internally published, but not published within the literature yet. But if you want to know, get a hold of me and I can share that with you. Within those 80 papers, there's some software out there called LitMaps, and it can show you the linkages and connections of that data set through their related citations. So the earlier published papers are to the left-hand side, and they progress to the right-hand side based on the publication date. And the size of the orange circle represent how many times the paper is connected or cited by other papers. So heavily cited papers like the Boccoletti 2006 paper are larger orange circles than Wang's 2014 paper that shows no other connected citations. And basically one of the things that was useful for AstroExcel was just what are the big papers out there? What should we be knowing? What is the research already out there, and who's citing who, so that we know where this interesting data is coming from. So what did we find? So across those 80 papers, what makes a network effective? What's the learning here? What's the take-home message for people who are trying to build a network of networks? How do we do that effectively? And if you read across those 80 papers, the things that came out are not, this isn't rocket science, but pulling it together coherently and clearly was that there's one, you need proactive engagement and openness. And what they mean by that is you need to actively, not just by happenstance, but actively seek out new connections and opportunities to share information to expand the network's reach and resource base while fostering a culture of transparency and trust. And that's really important. That transparency and trust really brings that openness to actually be useful. Again, trust and reciprocity is incredibly important if you're trying to build a network and make it more effective. And building that trust over time through consistent interactions and ensure a mutually beneficial environment where members support each other, reducing the need for monitoring and enforcement. And building that trust and reciprocity does take time. And unfortunately, one of the realities is that grant cycles usually don't work on these longer timescales. So again, NSF funded us, for 3 years, and we're already all the way in, we're pretty much through year one. So how are we gonna build trust and reciprocity quickly so that we can all work to make this network grow as effectively as possible? So those are the kinds of questions that we're looking at and asking of our members. We also need to create clear goals and objectives. So align and communicate clear goals to provide direction and coordination, ensuring members understand and commit to common objectives. And this is something that just came up in our summit, actually. A lot of people were like, wait, what's our goal? Like, where are we going back to? So even like going back to those goals and objectives, even after you sort of iteratively, before year one, we were like, oh yeah, we're super clear on our goals and objectives. But not everyone was part of the network yet. So now that everyone has been part of the network for some various form of time, really going back to those goals and objectives has been really necessary. Technological integration. When you're trying to create a network of network that works around the world with 24 different networks and 40 different people, you really have to integrate your technology in ways that can be effective. And we're still sort of struggling with that, because if a good meeting time is for somebody, one of our members who's in Australia, it's generally not such a great time for our members that are in England or Pakistan or Iran. And so we have people in Japan, we have them on the US, all over. So we've tried to work with technological integration using Google Docs, using Slack, using synchronous time of meetups, but also asynchronous ways of trying to integrate and make sure everybody is getting the information and sharing information. We need to balance formal and informal structures, so we combine formal roles and responsibilities and informal networks to foster flexibility and innovation, where formal structures provide clarity and informal networks enable spontaneous interactions and idea sharing. And that's where we have what I mentioned earlier was what we call the COG, which is the Council of Government. So that's more of our sort of formal structure. Those are the people that are looking at the big picture strategic planning. And our more informal structures are within those mini cohorts and within that group. So there's a lot of flexibility between the roles and the levels. And we also are embracing diversity. So bringing together diverse network members with varied skills and perspectives to drive creativity and adaptability, leverage the collective strengths of the network. And this is one of the things that we took very seriously and had a very hard time doing when we got those 150 applicants for 12 members for the early career researchers. We actively said we are going to choose based on diversity, but how do you do that in a really authentic way and think about all the different types of diversity, not just maybe the country that they represent, the networks that they represent, the gender that they represent, the language that they represent, the work that they're working on, and how you represent that. So thinking about diversity across the network with only 40 people is a challenge, but something we're trying to work on and is something that is really exciting. So one of the things that I've been talking a lot about is breaking down that research to practice silo. And so we think a lot about how do we work in applied settings? What does it mean? If we have a really cool finding in astronomy and straight up science astronomy, what does that look like on the ground? How are we going to educate about it? What does that look like in engagement circles or in our communities or in our culture? And how my question in the research circle is, how can we utilize networks of networks in these applied settings so that we can leverage this work to get that knowledge out there more effectively? So that's my role of trying to ask those kinds of questions. And so what did the research say, right? Again, I went back to that literature, those 80 papers, and I was like, okay, what did they say about how networks of networks can be applied, but applied within astronomy settings? And what the literature says is that it can be really useful for education initiatives. So networks of networks within astronomy can be really useful when you're thinking about education initiatives, when you're trying to think about mapping. You can use them to map relationships between educational institutions, research centers, and outreach programs to facilitate coordinated astronomy education programs. Networks of networks in astronomy can also be useful in public engagement settings. They can be useful in identifying influential individuals and groups to effectively disseminate astronomical knowledge and engage the public. Networks of networks in astronomy can be useful in collaborative culture, so fostering partnerships and interdisciplinary research by mapping existing collaborations and identifying new opportunities. Cultural dynamics, providing insights into the spread of scientific norms and values to ensure the integrity and vitality of the astronomy field. Diversity and inclusion, creating inclusive and diverse networks to enhance creativity, robustness, and problem-solving potential. International collaboration, mapping global astronomy networks to facilitate worldwide collaboration and knowledge sharing. So if you think about the role of early career researchers in thinking about way of creating networks of networks in astronomy, these are all the applied ways that we're finding that they can be useful. And so if we think about what did we find within the literature on the gaps in underutilized methodologies. I'll skim through this very quickly if you're interested in really where the gaps in underutilized methodologies are. If you're interested in doing more research on social network analysis, networks of networks, those sort of things, it's an interesting space of thinking about. But basically, There are methodological gaps. There's some interesting ways to innovate our applications of astronomy. We can be much better on creating impact assessments and creating standardized tools to do this work. So addressing the gaps, though, will advance the understanding of networks in astronomy and help optimize the design of network-based initiatives to maximize returns in research, education, communication, and engagement. So what are the conclusions? What did we find? Sort of where are we and what are our next steps? So often when we think about social network analysis, it creates some sort of visual of what the network looks like. This is a ridiculously absurdly basic social network analysis diagram of what AstroExcel looks like right now. Each of these circles represents a person who then represents different networks. And we need to work on really enhancing our social network analysis, data analysis. And that's one of the things I'm frantically working on right now. So I was hired about 6 months into year one. And so I'm trying to get all the data from year one to then do that analysis. Because from year one to year two is going to look drastically different. Like just in the last 6 months was when we had the early career researchers come on, the associates come on, the mentors, the mini cohorts. A lot of this work and what AstroExcel looks like is very different from the beginning of year one to the start of year two. And so looking at that social analysis and the transitivity and the foldings within that network are going to look really different. So I'm trying to create those analyses to compare what year one to year two looks like and how we can look at that transitivity and folding across the network. Our findings, next we need to really think about the findings to report about AstroExcel specifically so that we can say, oh, this is what's useful for networks of networks, and this is how we can utilize each of the roles within it. So even thinking about like how to is setting up the network of networks this way really useful for early career researchers? So we can go into that data when I've asked the early career researchers and say, what's really working for you? Right now, the early career researchers, part of AstroExcel, are working on a white paper to share what works for early career researchers and how can we leverage their role within this work. So all of those kind of findings need to get reported out. We need to create findings that help the applied nature of AstroExcel, like what does that look like in practice? Where is that going? And findings that add to the body of literature on networks of networks development and breaking down those research to practice and practice to research silos. And collaborations and projects are underway. I've shared a few earlier, but there's many, many more. And so all these projects are just sort of just starting and just beginning and just getting established. And so we need to be able to share about those and report out on those. And I would say in order to leverage early career researchers within networks of networks, what we've really found so far from the literature and from our work that we are doing with our early career researchers is that it's really important to remember these considerations. We need to remember structural properties and dynamics. So if we can analyze the structure and behavior of networks, it provides insights into their growth, evolution, and functioning. We need to think about modeling and visualization. So network analysis tools can accelerate research, highlight key players, and facilitate collaboration. Even showing, when I showed that really super absurdly simple social network analysis visual to the group, they had questions like, well, wait, who's in the center and why are they in the center and where's that role? And thinking about modeling and visualization of the network can actually provide really interesting facilitated conversations about the network and how it's working and the functionality of it. Interconnectedness of relationships is really important to consider. Social relationships are essential for understanding the structure and behavior of networks in astronomy. And it's hard to sometimes do this work when we are worldwide. So how do we do that when most of the time we're on Zoom meetings for a few hours a month and only meeting in person once a year? So how do we make sure those relationships really are interconnected? And we're trying to do that in lots of different ways, but it's one thing to consider. Emergent properties and complexity. So networks exhibit complex interactions and behaviors not apparent when examining individual nodes. So nodes meaning like an individual person or an individual network. And the early career researchers have So there's layers, right? There's like there's a person within the Asterisk cell, and they are an early career researcher, but then I have there are 7 other early career researchers, and they have their own individual properties and complexity, but they also represent the early career researchers' properties and complexity, and they are within the broader Asterisk cell network of networks, and that represents its own properties and complexity. So thinking about all those levels at once is really important. And remember, there's also diverse network types. So astronomy networks can include collaboration networks, observational networks, information, organizational networks, and early career researchers can be part of all of those types. And we've seen them work in different ways across all of those different types of networks. So even if your network doesn't look exactly like Asterisk cells, or doesn't have the same focus areas, or doesn't have the same goals, early career researchers can be a part of all different types of networks, and we can really utilize their knowledge and all those skills that we talked about earlier to really enhance that network that they're part of. So I gave a really brief overview, so thank you for kind of going along with the Asterisk cell. I'm thinking about really kind of one case study, so if you have any questions, I'm happy to answer them now, or I have my contact information up there and we can chat later. Thanks so much.
Thank you, Anika.
Thanks. Any questions?
Yes. Anyone has some questions from the audience? I have one question that is related from the, what is the size of your study sample of the network of networks, the population reach, and what, yeah.
The population size. So there's 40 members, but they represent 24 networks. So depending on how you think about that, and if you're thinking about social network analysis, whether your node is a person or a network, it changes that. But we have 24 networks represented by 40 people.
Okay. And what do you think that you need to improve in your analysis?
I'm sorry, I didn't hear the question.
Yes, that I mean, in the analysis that you are doing in the network of networks, what do you think that you need to improve? I mean, in this.
What can we improve?
Yes. Yeah.
Well, we can improve a lot based on even knowing how we grow these networks. So a lot of times previous networks grow kind of randomly and ad hoc based on what are the different needs of the groups. And so one of the things that Asterisk cell is trying to look at is trying to grow more effectively. And one of the reasons why the literature review was one of the first projects that they wanted me to do was so that we could really learn from what does the literature already say? Like let's be research based about this, right? We all are researchers in some form or fashion. So one of the things that we really wanted to do was to grow effectively, and that's why there's also multi-layers of looking at all of this. So not only are we trying to leverage, especially early career researchers, to promote and disseminate the research that's out there and connect them to the practitioners that are actually also sharing and educating about that research, we want to evaluate how we're doing this work. And my role is to research those practitioners, the people that are part of Asterisk cell. So when they signed up for the role, I said, you have to, in order to sign up for this, you have to agree to being part of the research. You are a research participant. So that's what's really fun, is that we are not only researching astronomy, education, engagement, communication, and culture broadly, and thinking about how we break down those research to practice silos across those focus areas, but we're really researching ourselves as well.
Thank you so much for your answers. I think here online, Zach has a question for you.
Yes, can you hear me?
Yes.
Hi, Anika. Wonderful talk. I have 2 questions. One is, how long is program? Because it seems very interesting, but I don't know if there is a funding limited time. Maybe I lost it in the beginning.
Yes, so
And
it's
the
a
second one is,
Oh.
just continue.
It's a 3-year program that's been funded. We're in year 1. We just finished year 1, just in the last month. So it's a 3-year funded program. We just finished year 1. And the funding that is provided is really for research and evaluation, but also the people that are sort of official AstroExcel members are only financially supported to come to the summit each year so that we can do that work. So they're funded for their travel for 1 trip, but they're not paid for their time during the summit, and they're not paid for their time when they meet bi-monthly.
Thank you. And the second question related with what you mentioned about to help early career researchers in faculty positions. If the program is only 3 years, what are the plans to support that? Like to connect the researchers with institutions, or how is the plan for that?
Well, that's really the key between networks of networks. That's why they've really, being part of this, connects them to 24 networks around the world. So when we have those conversations about whatever their projects are or the projects that are happening across the AstroExcel, they're really connected to networks around the world. So one of our goals is to not only, at the end of 3 years, to be more sustainable ourselves as an AstroExcel network, but all the members, whether they're early career researchers or they're associates and they do more education, they are much more connected to all that, all of the networks that are doing all of this work around the world. And so there are roles for them depending on their interest and availability and the ways they want to engage. So there's a lot of collaboration. Like we keep talking, in so many sessions, I've heard, oh, well, we just need to do more collaboration. And we can collaborate. And there's all kinds of amazing availabilities to collaborate. Well, this is what AstroExcel does, is like deep collaboration across networks, across people, across groups, across all kinds of areas. So it's ridiculously deeply collaborative.
Okay, there is a question for the public, for the audience there.
I don't see anybody here who has a question.
Okay. So I think we'll finish. Thank you so much.
Thanks, everyone.
See you around. Bye-bye. Eduardo, are you stay there?
So, so the first one is online, huh? Hi, Mamta.
Yes, hello. Can you hear me? Am I audible?
Yes, I can hear you.
Morning. Good afternoon.
So you will be sharing a screen with us, now?
Yes, I'm going to share the screen.
Now, so they will introduce you first, and then.
Yes. Do you see my screen? Do you see the presentation?
Wait, give me a second. Give me a second. I'm trying to get. Okay. So, yes, can you make it large, please? Big size.
Yeah.
Full screen. Thank you. So give us 5 minutes. We'll be sorting out stuff now, and then we will we go ahead.
All right. Okay.
Hello. No. Is it on? Yeah. Okay. Can I start? I think Priya should start. No, these guys have to tell me. I am ready to start. I have to wait for that. Can I start? Okay. 1 minute.
The first one is
Mamta,
recorded,
yeah.
you know? Yeah.
No, I think she's doing it live.
She will be doing.
I saw
She's online.
Yeah, she's online. She's there.
Oh, what did I put? I put there my tea.
Did they say go? No. Do I start? Yeah? Great. Okay. Thank you very much. Sorry for keeping you all waiting, but there was a little bit of confusion, but I think that's fine. So hello everyone, I'm Priya Shah Hassan. I'm the co-chair for Women in Astronomy, and I'm so happy to have you all over here. And essentially we have 6 talks over here in this session, 15 minutes each. So every speaker after 12 minutes, I'll give you a this thing, and then let's hope we wind up. So we start off with the first talk, which is by the chair. This is the chair of the Women in Astronomy group, Mamta Pomier, and she's joining us online. So let's have Mamta online, please.
Right. Thank you very much, Priya. I hope I'm audible.
Yeah, you are.
Okay, great. Thank you. So welcome everyone to this session of Women in Astronomy Working Group of the IAU. And today's session is focused on empowering equity and welcoming diversity in astronomy. And we have a whole range of speakers from at different career levels and from different countries. So we'll be listening a lot of interesting talks in this session. So my talk is basically focused on addressing gender disparity in astronomy. The whole work was done with the current working group organizing committee members, and of course the participation that we receive from the whole community of astronomers worldwide. Thanks to their participation, we have managed to come up to the level of work that we are going to present today. So to start with, our working group started collecting data and studying a bit how the gender balance is presented in the IAU itself. So we picked up the membership data. And what we saw is that within the IAU membership data, there is a clear underrepresentation of women and non-binary individuals in astronomy. We can see that there are 78.7% male and 21.2% female and 0.1% unknown gender members in the IAU community. And we wanted to understand why do we have this kind of underrepresentation, and of course the main reason is the leaky pipeline and the glass ceiling effect that exist. So what are these effects? We will see a bit more in detail in later slides, but in order to understand this kind of imbalance that exists, what we did was we conducted a survey to understand what's the working conditions that are being offered to women in astronomy and why the representation of women is so low or so underrepresented. And we got a very good response from almost 750 members from the astronomy community worldwide, with more than 50% participants from the EU countries, followed by Americas, Oceania, Asia, Africa, Middle East, and other countries. And what we saw from this data, the survey that we collected on working conditions for women in astronomy, is that at the PhD level, so around the age of 25, 27 years, we have a kind of almost equal representation of male and female students in astronomy, with 55% male and 45% female. But when it goes to the postdoc level, which can last from 6 up to 17 years or even later, which is in the age group of 30 to 50 years, we start to have a continuous decline of women in research in astronomy or in other STEM fields as compared to male researchers. And the proportion changes from 55% male to 75% female, male, and from 45% female to almost 25% female. And this postdoc or this non-permanent position stage can last for more than 50 years also, or they may never become permanent. But if they get into the permanent position, then too, which lasts from 36 to 46 years, the junior researcher position, we start to see 80% male and 20% female in research institutes. So there is the stage later, which is beyond 46 years. And at that stage, when you start to get promoted and you start to have senior positions, we have 95% male and 5% female, with only 1% female who managed to hold a professor position or a director position in their institutions. So what we see is there is a systematic kind of outflux or removal of women candidates from this pipeline, and very few female researchers are being retained. So there is a continuous leakage in this pipeline, and this leakage, the main reason is, of course, maternity. Most of the women in the age group of 30 and beyond start to embrace motherhood, and when they embrace motherhood, their policies are not friendly enough to help them to continue with their careers. There are some help offered now, but before there was less flexibility and less help which was offered. And as a result, they start to pick up all sorts of possible positions which can be provided to them, which can help them to maintain work and family balance. And somehow it doesn't work and doesn't help them to have permanent positions and even support. So there are not only these factors, there are several other factors. There is maternity and family responsibility. There are social stereotype. There is bullying, discrimination, lack of support at work, few job opportunities offered to women, lack of women role models. We don't see many role model women at different career stages who are trying to help this situation. Lack of flexibility, glass ceiling effect, unethical and unfair work evaluation, sexual and mental harassment, not enough support from the family, lack of motivation and self-confidence, which comes into picture after so many years of discrimination, imposter syndrome. So there are several factors which are affecting their career. And this data, which we see here, so we have a response from male researchers in permanent position marked in blue and female researchers marked in red. So there is lack of information which is not there and people are not perhaps aware of. So we wanted to bring all these factors into a proper statistical data so that people get to know about all these problems which are existing at workplace. And due to lack of awareness, support, positions, funds, especially after maternity, women researchers are often forced and even advised to leave academia. And this leads to a kind of a gender gap or lack of female researchers in STEM fields and in astronomy. And that later leads to unhealthy working conditions, as I mentioned here. So how do we solve this problem of leaky pipeline effect? The one thing to do is all the stereotype, bias, discrimination, and neglect of expertise is feeding into the glass ceiling effect. And that glass ceiling effect leads to gender imbalance. And this gender imbalance leads to this unhealthy and unsafe working condition that women researchers are facing, especially women, mothers. And how to solve this problem? The way to solve it is, of course, to provide funds, engage more graduates, which is happening. But after that, it's not about engaging graduates where at least we can still see a 55% male and 45% female ratio. We have to recruit more women postdocs, and we have to offer flexibility at work so that they can continue to work and produce results, and somehow they should not be seriously removed and discriminated out of the system. And the mothers who are working since more than 10 years and who are holding a PhD degree, their job should be retained. They should not be kicked off. And so that is only possible by providing flexibility at work because they have also family duties. And of course, we have to sustain the career of women researchers in order to achieve gender balance at workplace. Otherwise, this is not possible. So when we understood all this, we came up with a 4-point plan. And in this plan, what we wanted to do was to highlight the difficulties that the women researchers they face. Why do we have this leaky pipeline effect, which we don't manage to solve until now, and help bridge the gender gap in astronomy that we see, and to help the career of women researchers and young PhD female students worldwide. So for that, we came up with this 4-point plan. And in this 4-point plan, we focus on creating awareness and sustainability by engaging in, by through our newsletters, through surveys, through activities that we are organizing, by acknowledging the work of the female researchers, publications, etc., by celebrating their accomplishments. And we are also providing training and skill building in order to train young students and also early career researchers. We are also trying hard to get funds in order to retain the career or sustain the career of women researchers. And we are also doing a lot of dissemination and communication of our results in all conference meetings, workshops, and writing newsletters, etc. So for awareness and sustainability, we carried out a lot of different activities in last 3 years. So there are always series of talks by well-known researchers, but also by early career researchers. We also hear career stories from famous female astronomers, and we also provide mentoring sessions, and we also provide information about how to carry on with your careers if you don't manage into astronomy into fields which are closely related to astronomy. So we conducted several talks and series based upon that. All these talks are available on our website. So if you want to look at them, you can go to our YouTube channel where we post all these talks. We are also promoting girls and boys in STEM at school level. So we have been engaging students even at school level to participate in our activities. And otherwise, we have been making short videos to encourage them. And we have been putting it on our website to encourage young students. And just now, not only young kids from school participated, but also college level students have been participating in our activities. And also the researchers worldwide have been posting their videos to encourage young students to take up astronomy as a career, especially young girls. We are also being invited by schools and college and universities to give talks on International Women and Girls Day and also International Women Day. And we are going there, and we are also presenting our work or presenting some activities that can be done in order to expose girls to a research career, because we are not telling them now to just draw an astronomer. We are asking them to draw yourself as an astronomer so that they can focus this as also a way or see themselves in this kind of career, and not just draw any astronomer which comes in their mind. We are collecting a lot of testimonials on working conditions of women in astronomy. And of course, we get all sorts of very how would I say, difficult response from people who are facing difficulties, who are facing discrimination. They are always being paid less. They are not being paid equally. They are being paid, given part-time contracts or unpaid contracts. They face, especially women of color, face a lot of discrimination, and they face a lot of unfair working conditions. Not only this, there are young students who are also facing a lot of problem in research institutes, and that may even lead to suicidal mentality and depression. So there is a lot of mental health issues which are rising. And
Mamta, 3 minutes more.
Yeah, not all harassers are men. Some harassers are also women. And so it's not about men and women. It's really about how the EDI policies are there and how all these problems are being tackled at the institute level. There are also all sorts of training programs that we have conducted. We got very good feedback. So Priya will be talking about it. We made an attempt to get funds. Of course, we did not get funds because there are no well-focused funds just to support all sorts of diverse activities that one can do in research for women. So, of course, I managed to get some funding to support a PhD and a postdoc. So I'm sure other researchers are doing the same. And if you have such jobs which can hire more female astronomers or students, then please let us know so that we can advertise it on our website. And we have been also requesting the executive committee in last 3 years to acknowledge the work which is being done by many STEM ambassadors worldwide in order to have this kind of STEM ambassador recognition award. So all our work which we are doing and the communication we are doing is all documented and it's available on the IAU website. You can refer to it. We have followers from more than 93 countries. So they are following our activities and they are participating in our activities. And also, I can quick. So all this work which was done was mostly done by unpaid. I mean, it is all volunteers, as we know in the IAU community, that these are volunteers. They're not paid to do this kind of work, but they are doing it out of willingness to help and support the community. All this work took almost 3 years 3 months per year, an equivalent amount of salary to help the community. So of course it is all unpaid, but this is what it demands in order to bring up all these problems and to create awareness. So I'm very proud today to announce that finally IAU has, Executive Committee has accepted our request and we are launching the STEM Ambassador Recognition Award. It is for the first time in the history of the IAU since its founding in 1919. So it's really great. And of course, it happened on 9th of August, which is the National Women's Day in Africa. So we are very happy and we are very pleased with this news and we are very happy to share it with you. If you want to know more about it, you can write to me. And we wanted to see if there are more STEM ambassadors all over the world who are doing this activity. So we asked for call for nomination for recognizing champions of gender equity in astronomy. We got nominations for male and female researchers who are having permanent and non-permanent positions. And most of the nominations are coming from America, UK, and EU countries, followed by the other countries. And the main reason is because US and UK have EDI policies implemented in their workplace, which other countries don't have. So that's the reason why we have more nominations from those countries. And there are individuals who are being paid to do ADI activities at their institute. But the nominees are usually in the age group of 35 to 45, which is when the leaky pipeline effects start to affect their careers. So they are actively participating in these activities. So this is almost my second last slide. What I want to say over here is that it's very important to have correct policies at workplace in order to have gender balance and inclusive working environment. And these policies are basically fed by the funding agency, universities, and journals. And mostly it's the researcher and hiring committee who are playing the role to define and help these policies in order to achieve the gender balance. And somehow grant agency editors or universities and institutes should support these activities and should fund only activities at least where there is some effort towards gender balance being mentioned at the workplace. And if this is not done, then of course there's a lot of competition, conflict of interest, deteriorating working condition, and rising issues of change in leadership and unfunctional administrative situations at the workplace, which we have seen already. And the solutions are, of course, to maintain a transparent feedback mechanism and fair evaluation and gender balance at workplace, and publish regularly these results. So that's my concluding slide. So these policymakers are basically feeding the system, and somehow we have not managed to achieve gender balance yet, or it's happening at a very slow rate. And gender balance champions are doing a lot of job, in fact, to achieve some kind of gender balance at workplace. So we should acknowledge their efforts. And I would like to stop at this. And I would also like to thank our organizing committee members and other members who have been participating in our activities, because they are the gender balance champions who are helping us to promote this.
Yeah.
Thank you.
Thank you, Mamta. Thank you so much. Thanks for a lovely talk. But since we've exceeded our 15-minute limit, we'll move on to the next one. Thanks a lot, Mamta. And so the next talk we have is by Mariana. Mariana is going to talk to us about the work and achievements of African Network of Women in Astronomy. Yeah. Thank you.
Thank you, Priya. So good afternoon. While we are waiting for the presentation to be displayed, so good afternoon, everyone. Thank you very much for being here with us. So in the name of the African Network of Women in Astronomy, I will just introduce a bit the network as currently the chair. So just a little bit of introduction. So basically that a bit brings us why AFNWA is important. So here we can see from 2019 one of the latest reports published by Women in Science group under UNESCO, where we can see what is the current status regarding the fraction of female scientists across the world. So when we come to the African continent, the fraction is, the percentage is varying from 50%, like in countries such as Tunisia or Algeria, South Africa as well, but also it goes all down to 5% that out of all scientists are women, like in Chad or Central African Republic. In Ethiopia, where I'm currently based, it's only about 13% of scientists that are actually women, which means that still there is a lot of, so in average, if we take all African countries, we have that less than 25% are female scientists out of the whole population. We know that astronomy really now, we have so many proof that astronomy really contributes to all sustainable development goals. In this slide, we can see the 17 goals, and we can really say that without Sustainable Development Goals 4 and 5, which is improving education and bringing the education accessible to all children, and then putting the effort that we have really gender equality, so empowering girls and women and minorities across the world. Without that, we cannot really speaking about achieving any of the other Sustainable Development Goals. Then in addition to all of that, astronomy is really emerging science across the continent. And when we take into account all of this, it really brings to the need to have the African Network of Women in Astronomy, so a type of network that will bring all women that work as professional astronomers across the continent, and then female students as well, MSc, PhD students. So basically in 2019, after I got the Nature Research Award for Inspiring Science, I wanted half of that award to go for creating this network, another half for work in Ethiopia with the girls that we've been involved. And then in touch with 5 other female colleagues, we started AFNWA. Basically with the principal aims, as you can see there, to improve the status, so to help that we have more female astronomers, but not only astronomers, women in science in general across the continent, then to guarantee, because as I said, astronomy is an emerging science, so we want to guarantee the participation of women in all developments of professional astronomy in Africa. And then to use actually the network so that we can empower girls and women across the continent and inspire them to do STEM, and then empower them in general. So basically we established AFNWA in 2020, and we approached the African Astronomical Society that was re-established in 2019. And in 2020, AFAS already was on its feet. No? So it started already with different activities. So we approached the executive, at that time, the executive committee. We said the initiative that we have, and since our goals were in line with the goals of AFAS, we just brought the idea that we work together under the same umbrella. So starting from 2021, January, we launched publicly AFNWA as one of the committees of African Astronomical Society. So here, okay, this works. So here you can see the current board. So the initial members were Somaya from Egypt, Priscilla from Uganda, Vanessa, and then Nana, who is here, and then our Carolina, who passed away 2 years ago. We currently, a few months ago, we opened the call for 2 new board members. So we got Miriam now, and we got Nana as members from Morocco and Ghana, and Salma from Senegal joined about a year and a half ago. So currently there are 7 of us. And we have currently more than 100 members. AFNO is very open. There is no any membership fee. You just have to fill a small form. You become a member independently where you are based, independently of your gender as well. So all our activities go toward women and girls, but anyone can be members. So we basically have about 20% males, 80% female members. We have members from more than 30 countries. The majority are African countries, but not only, we will see that. And what is very interesting is that about 80% are actually early career researchers, which means MSc students, PhD students, and then young postdocs, which means that AFNO is really timely so that we can really bring the network, all community together. Follow up the track, the professional path, and guarantee that women really stay in astronomy and science and help each other. So here you can see the current distribution of members. And as I said a bit, that we are, the initiative is really timing for strengthening the links between female researchers, the improving the leadership skills, and then attracting more girls doing more activities in that regard. So now in the few slides, I will speak a bit more regarding the activities that we've been doing. So we spent quite some time in creating the network and then giving the visibility to the network. So AFAS really helped a lot in that, using different networks through AFAS. We created the email list, and then now through that email list, we really keep in touch. We send different opportunities regarding the scholarships, funding, different activities that are going on. So keeping that network through the email list really helps. We started with community meetings. We want to bring that on more regular basis, so that basically on every month or 2 months, we really meet among the network members and just have informal discussion about how the general situation is. We did several virtual trainings for early career researchers. To do that, we did, when people signed the form to become a member, we also asked what kind of trainings they would like to have. So we used then that to approach possible trainers and then organize the trainings. You also organized several public events. Most of these were virtual, but there were also some in-person events in different countries related with women in astronomy and women in science. We also, in the last few years, since the establishment, started organizing the discussion sessions about women in astronomy and then women in science. So we used several meetings. Every year when we have the AFAS meeting, we organize the session about women in astronomy in Africa. And then every time that we have a certain astronomy school running, any kind of workshop or any kind of conference that is there going on, in particular across Africa, we do involve the session about women in astronomy on the continent so that we can really discuss and get different feedback. We also participated in several sessions related with Africa, European Union, and then United Nations conferences. And this was done now for the past 3 years. 2 years ago, we organized, AFNA was the principal organizer in one of the Africa EU sessions. We organized a session. It was the whole, like a half day, about women in science movements across Africa, which was really, really inspiring. And we are still working on coming up with the publication from that session. We came with a draft and, because we are all volunteers at the end, we were so busy and it didn't come out, but it's still there as something to be done. And it's actually amazing how much, not only in astronomy, but when you look at all different fields of science, how much different movements are there across the continent. However, much less than when you go to Europe or when you go to US and then you have different states and so on. So there is still a lot to be done. And that was one of the conclusions that we also got. We also developed a list of recommendations, about women and girls in science, in astronomy, and that you can find on our website. So every time that we do organize different conferences, meetings, we actually share this list of recommendations as well. The outreach activities is something that we started organizing as well. Last year, we worked on 2 outreach videos. There is outreach video 1 and 2 that are available on the YouTube. And these 2 videos, if you just go to the YouTube, you put AFNA outreach videos, you will get them. And these 2 videos have been done with women in astronomy across the continent, young researchers and then senior researchers as well, that they just share their story. There were like 4 principal questions, just the basic representation, the message to the young girls, the type of science they do, so that in the schools, the teachers can just play these videos and then get inspired. So we also had few undergrad students, like this student here that you can see, the physics student that you can see at Mbarara University of Science and Technology in Uganda. And we know that 3 minutes. Okay, thank you, Priya. And we know that already they have been presented in different schools across the continent. Another activity that we started in 2021, so just 1 year after AFNA was officially established, and the first year when it was launched, was the very first awards for women in astronomy in Africa. So here you can see our awardees. So we have 2 awards. One is for early career researchers, PhD students, MSc students, and young postdocs, and then for senior researchers, so more than 5 years after their PhD. So you can see Mari and Rene, that were our first 2 awardees for early career and the senior, then Al-Shaima for early career in the 2022, and then Brenda, she's here, and then Hasna, the early career and the senior, that was this year the 2 awards. Last year, we renamed, in tribute to our friend and colleague Carolina Odman-Govender, the early career award into Professor Carolina Odman-Govender early career award. So this year we will have another awards given. So the senior is every 2 years, and then early career every year. This is another activity related with reaching more girls and related with outreach. So this year, this year was the first year that we opened the call for seed grants. So this is really like a small funding, 250 to 300 euros that we were able to give for any kind of project across Africa that is focused on promoting STEM using astronomy among girls that live in and study in challenging conditions. So that includes girls in remote rural areas, refugee camps, internally displaced girls, young mothers, like minor age mothers, girls that work in townships and so on. So the feedback was actually amazing, considering that it was the first time that we did it. So we got 30 proposals across the continent, and it was amazing because we got projects proposed going from undergrad students, teachers from the schools, all up to the senior astronomers. So finally, with the funding that we had, we were able to support 13 projects from 10 different countries across Africa. We already started getting the feedback from the activities that were carried out, and most of the activities were focused on girls living in remote rural areas, IDP camp settlements, and then townships as well, and the refugee camps that I forgot to include here. And to finalize, this is again one of the activities. It's the very first book about to give more visibility and recognition to women in astronomy in Africa. So here is the first edition. So you can see, I mean, the book has just been printed, and this afternoon, we are getting the first 50 copies. So this book is sharing 50 inspiring stories about going from MSc PhD students up to the senior women. Prissy was our main editor. It was done in help of all the design, in help of the African Science Stars that did a great job. So we got about 50 women who shared their story. The books are there that you can get a free copy. From 22 countries. And this is a bit the type. So we have each colleague have its affiliation, quote, a bit like a message, her story, and then the awards that they got. The coming activities that are there will include a bit all of this. So we are getting, I mean, here are the first books that we want to share. So if you would like to have a copy and then it's really a bit like a telestorying book, the storytellings for like really inspiring the girls. So can I just finish with this? Yes. So in order to join, I mean, please join the AFNOA efforts, even if you have just a bit of time. There are different possibilities that you can do within your capacities. So first is that you can participate in our activities. First is that you can just fill the form, you become our member, you join to the email list so that you can keep up with activities that are going on. Then please strengthen your research with female astronomers across Africa. When you do your research collaborations, you write a proposal for telescope time, you write proposal for funding, please think about women in astronomy in Africa, especially young early career researchers, so that you can bring them to your projects and that you can involve them in your networks. Share training and the human capacity development opportunities. So once you become a member, you can send the information through the network. Please host African female astronomers at your institution. Johan is here, who already started doing a great job bringing women to the IC through the Women for Africa session. We have Anchon here. I hope that's a great potential that we can also bring at the IEA. And actually, we do have, IEA is also doing a great job already. Brenda was there, Liz was there, Miriam was there, and so on. Please do the outreach activities in collaboration with AFNOA, so follow the activities that are there, and then you can also include the recommendations that we are giving in your policies and strategies. So independently where you are really welcome. So thank you very much. And take the copy of the book.
So thank you, Mariana, for a lovely session. It's so good to see all your activities, but we've got a very long way to go.
I know.
Very, very long way to go. But yeah, all the best. And I think this is really good.
Thank you.
I'm sorry we won't take questions now. We'll move on to the next speaker. I think we'll leave the questions for the ones who are willing to stay on longer, right? So we'll start off with our next, the next talk. This is by Asha Setback, and she'll be talking to us about the ICRAR Visiting Fellowship for Senior Women in Astronomy. So it starts off great.
Thank you, and it's quite an honour to be able to be up here and share the story. On behalf of Dr. Renu Sharma, she does pass on her apologies that she wasn't able to be here today as well. I also want to acknowledge that I come from the land of the Wadjuk Noongar people over in Perth in Australia, some of the oldest storytellers in the world, and it's an honour to be able to share some of these stories this afternoon as well. So hopefully the slides will come up soon. So I'm Asha Stabak, so I'm our Translation and Impact Manager. So I've run a series of different programs that sit across ICRA, and as well as being the current chair of our Development, Equity and Inclusion Committee on the UWA node of ICRA. So for those who are not familiar with who ICRA are, we are based over in Perth in Western Australia. It's a joint venture between two universities, Curtin University and the University of Western Australia, and we are supported through government funding from the state government of WA as well. So we were established over 15 years ago, and we have research nodes at both universities with significant contribution into our undergrad programs that are at each of the universities. But predominantly we support more at postgraduate level students as well. So over 250 of us, as well as a dedicated team for translation and impact, and our outreach and education team as well. So we predominantly came into existence because of the SKA. So we've now grown into this internationally renowned multidisciplinary research centre. So we do have not only the science across both of our areas, but we also have engineering, astrophotonics, and our data team as well. And as I mentioned, I'm part of the translation and impact team that sits across both of the nodes, supporting the transfer of knowledge and career advancement as well. So our inaugural executive director, Professor Peter Quinn, strongly recognised the need for, and I'm focusing on gender diversity, but more broadly around diversity as well. He shares some of his experience coming from ESO. He recognises him being a fairly privileged white male. And then when he went to ESO prior to establishing ICRA, he suddenly had the opportunity to see what diversity was actually all about. And he said he learned a lot through that. So then when he came to set up ICRA, it was a little bit by necessity that we actually had to have such a diverse group, because we didn't really have any astronomers there in Perth. So we really had to attract people to come and be based in Perth as well. So some of the more female-specific initiatives that we've put in place, so we've had women-only permanent positions for some of our researchers. There's childcare provision. These things are on top. I'm quite conscious that Australia and Oceania is well advanced compared to some of the other areas as well. So there are a lot of support schemes already in place for parents, but these are some additional programs that we have put in place at ICRA as well. So we've got childcare provision, nursing rooms, the primary carer support scheme. So this is a program where we provide funding for carers where they are travelling. I myself am currently benefiting from it as I've left my child behind. And so it's a flexible program that we actually offer some extra funding to support the development of our carers. And then, of course, I'll be sharing more about our Women Plus in Astronomy Fellowship as well. So the way in which we achieve this, we have dedicated committees at both of our nodes, but really what is most important is an executive level engagement and support who actually put funding and resources towards these initiatives as well. We do have ongoing evaluation looking at our hiring and promotion criteria, the statistics. We're constantly evaluating the programs that we are doing. I am doing a talk later in the week on our diversity, equity, inclusion, but this one I'm just focusing on our Women in Astronomy Fellowship. So it was established in 2014, and I do need to recognise that this was Dr. Renu Sharma who recognised the need. She is our Chief Operating Officer at ICRA, and the importance of actually having role models. It was at a time when they were just starting to bring in women-only recruitment as well to try to have more balance in terms of the gender equity. And so, she put it forward, like we need to actually fund, astronomers from around the world to come and spend some time with us here at ICRA and actually share their knowledge, their expertise, and foster that collaboration and knowledge exchange as well. So from her view, it was really about having that confidence, that visibility, and making sure that people were empowered as well. One of the big things, and recognising some of the talks earlier of the leaky pipeline, part of this, having these role models was people who have sort of pushed through and are progressing in their career, being able to share their stories and the strategies that they employed to be able to navigate their career. But at the same time, recognising their scientific expertise as well and making sure that there was contribution and collaboration at that level. The main focus was for our students and our early career researchers, also recognising that that was where the bulk of the females actually are. Like many of you, we do have, a little bit of that leaky pipeline. We're so nowhere near having a gender balance as well. But also for the fellows to gain from the experience. So it's 2 months that we fund people to stay at ICRA. I don't know about you, Curtin and UWA are only about 20 minutes apart. There is a river in between, and it may as well be a separate country. Trying to get people to foster connection and collaboration across 2 nodes, it does come with its challenges. So we do ask 2 months so that people do have a balance across both of the locations, but we do a lot of things online as well between as an entity. So we provide a generous living allowance as well as additional funding and support for carers, and all travel costs are covered for the time as well. We do have people coordinating at each of our nodes, offering support for the fellows. And then the expectation, as I mentioned, is all around actually immersing in the programs, the seminars, everything that we have on offer. So there's, like many joint ventures, you've got things that are different at each of our nodes. Mondays we have our journal club followed by lunch together at Curtin, and Fridays we have morning tea at UWA, so people get together in those informal ways. So who are some of the amazing women that we have so far had with us? So most recently we had Professor Prajval Shastri from the Raman Research Institute, as well as Dr. Maria Grazia Labat from SKAO. They were meant to come in 2020, and we all know why that didn't occur. However, you know, it was great that we were able to bring them both over later on as well. Professor Lilia Ferrario from ANU came over in 2019. Associate Professor, I believe she's now Professor level, Anna Frabel from MIT. We've had from ESO, Francesco Primus, Vanessa Smolcic from the University of Zagreb, and our very first one was Dr. Andrea Font from Liverpool John Moores University. So you can see that they've had a really diverse perspective. Would absolutely love to see someone from Africa as well in the future. So here's just a few happy snaps of some of our fellow alumni. So we have as a scientific exchange, so where they're delivering talks. We also encourage getting involved with our community and outreach events. So Prajval Shastri is there at our Astrofest. And then you see Anna Frabel as well, was able to bring over her child to experience some time in Perth and our sunshine. But really, I think one of the most powerful things is the different network and connections and collaborations that these brought about. So you'll see down here, so Prajval and Cheryl Prager is a sort of globally renowned maths professor. Now, despite her office being about 20 metres away from us, we had never actually connected until Prajval bumped into her at the airport on her way coming to ICRA, and that connection was able to foster greater collaboration with our maths as well. The young student that you see with Prajval there as well, she is a very passionate astrophysicist. At the age of 8, she is studying 3rd year pure maths at university, and she's been able to be brought into the network, and her development as well supported through us as well. So some of these things we can't really quantify what value it brings, but I know that we are contributing and having an ongoing impact into the astronomy community. So as I mentioned, we're fostering these connections, these collaborations, but also bringing different perspectives. Each of the fellows are invited to provide us with feedback and contribution to our development, equity and diversity initiatives. And they also take some of their learnings back to their host place as well. They continue to be role models and mentors and foster those connections and collaborations beyond the time of their fellowship as well. Particularly for our focus on the SKA, it has led to some direct sort of collaborations and also enabled us to have some key contact with people in different positions across the SKA as well. And we were delighted to see the Professor Frabel receiving an award for her LEAPS program. This is a leadership and professional development program that she developed at MIT. However, she actually really recognises her fellowship at ICRA as being key to being able to develop that program, test it out with our staff and students, and have that time away from her, busy professional career to really focus on that and build that program as well. So are you a future fellow? So it is open until the 2nd of September for next year's intake. I'm delighted that, and unfortunately she's speaking at the exact same time as me now, but Dr. Jarita Holbrook will be our incoming fellow for this year. However, this is for anyone that is looking to come to ICRA for next year. So we ask that you're about 5 years post-PhD. We're fairly flexible on the timing around it all. If you log on, you'll be able to see there's a form, and we strongly encourage some extra applications. Thank you.
Thank you, Asha, for a lovely talk. And I'm sure a lot of people are excited about this. Thanks so much. And sorry, we'll do the questions later. Yeah. So let's move on to our next talk. We have Brenda with us, and Brenda is going to talk to us about Mujeres. How do you pronounce that?
Mujeres.
Mujeres for Africa, a case study for research and collaboration opportunities for women in astronomy. Yeah, take it.
Okay, so hi everyone. Okay. So because of time, I can introduce myself. Hi everyone. My name is Brenda Namumba. I'm a postdoc fellow at Wits University in South Africa. I'm going to present about the Mujeres for Africa Foundation. This is Women for Africa. And I'll mainly focus on research and collaboration opportunities for women in astronomy. I should mention that I'm presenting this work, but I have collaborators. Some of them are in the room and some of them are online. So to begin with, my previous speakers have actually highlighted the many challenges faced by women in STEM, and some of them include societal stereotype. We know that at an early age in most African countries, there is a notion that STEM fields are more suitable for men than women, and that tends to produce a fewer number of women in STEM later on in our careers. There's also the absence of role models in STEM-related field in most African countries as well. This picture that I'm showing here just shows 3 women from 3 different countries. We have Marie from Burkina Faso, myself from Zambia, and Elizabeth Nalumisa from Uganda. So as in 2019, this was the first time we were having the first graduates and PhD, and that can tell you that there is really lack of role models in these STEM fields. And as we go further in our careers, there's also a lack of support for women who choose to start families, maternity break, and if they take a maternity break, when they want to come back, it's very difficult to fit in as they have to compete with people who did not even take a break. So the question is, with all these challenges, how do we actually retain a small number of women who have graduated in STEM fields, such as astronomy? And we have women across the world that are very passionate about seeing that women are actually retained in STEM field. And one of those women is Maria Teresa de la Vega. So she's the former vice president of the government of Spain, and she actually started this foundation, Mujeres for Africa. I had an opportunity to actually meet this very amazing woman, and if you hear her story on how she actually came about with this foundation, you will be amazed. So she actually had contact with women in Africa. It's not that she did not create this group by reading what happens in Africa. So she had contacts with women from Africa, and she saw that they had a drive. Given the opportunity, they could actually take part in developing their countries. And so she started this foundation, and the objective was to actually allow women to contribute to the development of Africa by supporting them. And the vision of this foundation was actually to promote a fair, inclusive, and equitable development for Africa, in which women are free to actually take part in different developmental activities that happen in their countries. So the Mujeres for Africa actually covers different aspects: democracy, governance, peace, human rights, media, and science through grants, fellowships, and meetings. In this talk, I'll just focus on science, and that's what I'm going to highlight because I actually was one of the fellows of the science fellowships. So Women in Science Fellowships were actually created for early career researchers. So early career researchers based in Africa to lead the continent's transition to economy based on knowledge and innovation. We know that knowledge is power and education is actually very important if we want to see Africa become self-sustainable. So the aim is actually to support women by connecting them to world-class facilities in developed countries so that when they develop that skill in these developed countries, they can actually bring it back to Africa. And the other thing is, as I said earlier on, we have very few role models in Africa even as at now. So the aim is to actually visit these world-class facilities, find career mentors, and then from this, after being mentored, after being mentored, they go to Africa and start mentoring the young girls. So this fellowship is actually a 6-month fellowship. You get to visit one of the world-class institutes in Spain to do your research and also form collaboration. So one of those world-class institutes that you can visit if you are doing astronomy is called the Institute of Astrophysics of Canary Islands, or of Canaries. And this is a world-class institute that is recognized by the government of Spain. So it is based, if you don't know where the Canary Islands are, they are just somewhere here. And then they have 7 different islands. So this institute actually is situated in Tenerife. And also they actually they run 2 different world-class observatories as well. So we have the Teide Observatory. This is me during my visit to the institute. This is Teide. We visited this observatory, as well as another observatory in La Palma. So the ISC, if you happen to go to the ISC provides access to facilities, including telescope, and also stimulates long-term collaborative links. I should mention that I spent 6 months here, and I formed very good collaboration with the people that I worked with. We are still in collaboration. And also the ISC working with the Women for Africa have developed other fellowships. So you will expect more fellowships to come up as they will, the regional government of the Canary Islands is actually putting in more money so that they can fund more African women to visit these institutes. Okay, so in 2021, during COVID, I had an opportunity to be awarded this prestigious fellowship to spend 6 months in the Canary Islands. And I was working with Johan. He's there, he is in the audience there. He is in the audience. And this is just me with some people from the ISC. We visited one of the observatories. So my aim of applying for this fellowship is that my goal is to open Africa to the world through scientific research and collaboration. So I knew that by me visiting this world-class institute, I will have an opportunity to work with the expertise in the fields of astronomy, and then also taking my expertise, like in radio astronomy, to the ISC. We can form very good collaboration and also take part in cutting-edge scientific research. So why did I choose to go to the ISC? So I mostly do my research in radio astronomy, but for a long time I have been wanting to expand to multi-wavelength studies. And I know that the IAC has experts in optical astronomy. So I said this is a good opportunity for me to learn something new in optical astronomy so that I can actually expand my expertise. So I worked with Johan and Jesus and Harvey. And when I was visiting the IAC, I had radio data. I'm a radio astronomer of one galaxy, which is NGC 6822. I didn't have knowledge in optical astronomy. So we said, let us collaborate and actually be able to look at this galaxy in multi-wavelength analysis. So some of the results that we were able to publish, this paper was published last year, is that using the H1 observation, in which I'm an expert, we discovered two newly discovered H1 companion of this galaxy. It was previously known to be an isolated galaxy, but with deep Meerkat observations, we were able to detect two new dwarf galaxies. And then in optical studies, one thing we did not see from the H1 observation is the link between the detected galaxy as well as the main galaxy to see if there's any interaction. So we tried to look at the optical data, and we found that for one galaxy, I think it's this one, there was excess light in the outer regions of this galaxy, which could be an indication that there was a possible interaction between these two systems, and they might have interacted even if we don't see it in H1. And that's the most important thing at looking at things in the multi-wavelength studies, because you get to have an overview picture of what you can see at one wavelength. So I'm not the only one who has gone through this prestigious, who has been awarded this prestigious fellowship. We also have Mariko Saga. She's a lecturer in Burkina Faso. She should be in this room. So she spent her 6 months at the Canary Islands. She's here, and she's also here with Johan. And they managed to actually publish this paper. During her visit, they worked on this paper, and it was published. So she actually gave this point regarding the ISC visit. So she had an opportunity to actually visit 2 observatories, and this allowed her to better understand the process of observation, given that she uses observation data more frequently. And the most important thing is that she is able now to transfer the knowledge that she got at the ISC to Burkina Faso, because they are actually planning to install a telescope in that country. So we have also Fesesani Vanzel. I hope I have mentioned the name correctly. So she is one of the recipients of this fellowship, and she hasn't yet started. Okay, she hasn't yet started, but she will be going to the ISC, and this is what she said. It's a catalyst for accelerating African scientific advancement, and through this, she hopes to aspire young girls to actually take up astronomy as a career. We also have Mona from Morocco, Egypt, okay, oh, sorry. We also have Mona, who will actually be going to the ISC just in a few months, and she is very optimistic of what she's going to get from this visit, and she hopes to actually transfer knowledge back to the institute where she's working in Egypt. We also have Elizabeth Nalumisa. So as you can, for Elizabeth, she is a lecturer in Uganda, and she has a 3 months fellowship, but very flexible, because they realize that there are some African women that are teaching, so they cannot take the entire 6 months at once. So they actually have 3 months fellowship that are flexible. So she went for 1 month and went back to Uganda. She will go again, and she has formed collaboration and also training for postgraduate students. So like have a couple supervisor from the IAC and Uganda. Okay, so this is my second last slide. I was talking about astronomy, but when you actually become a recipient of this award, you don't only interact with people in astronomy, we have others as well. I had an opportunity to actually meet Marie from Senegal. She does something in biosciences, and also Lola, who does oceanography. I think we got the fellowship in the same year. And then we also have Baida from Morocco, who also does something similar to Marie. So you actually belong to a larger community that shares a common good on how we can use education to actually develop Africa. So the last slide is the 10th call for this fellowship is actually out. You can just go to this website and then submit your proposal by the 30th of September 2014. If you have any question, you can actually contact this email. They are very fast at replying. Or if you are interested in visiting the ISC, you can actually contact Johan. He is very good at replying, and he will give you a very good overview of what you expect when you visit the island. And you can also talk to me and other people that I have mentioned during the IAU if you are interested in applying for this prestigious fellowship, and I will encourage young career researchers to actually take up this opportunity. Thank you very much.
So thank you, Brenda, for a lovely talk. Please stay on for your questions after the session, please. I feel bad to be discouraging people from asking questions, so please hold on. We now have our next talk, and our next talk is by Katikani. And Katikani is going to talk about women in physics, inclusion for all. So please do keep your questions for later. Otherwise, I'd feel very bad.
Good afternoon, everyone, and thank you for joining me for this wonderful presentation I'm about to give you. So my name is Katekani Shingange. I come from Minteg. It's a mining council research found in, it's in South Africa, in the province of Gauteng in Johannesburg. So Minteg has got different divisions within it, and I come from a division called Advanced Materials. I'm a scientist there, from a research group called Nanominerals Unit. So our purpose is to uncover new properties of nanomaterials, provide material support to research and development units, scale up and commercialize nanomaterials. We're also involved in human capital development, and we're also known as the launchpad for new technologies. Okay. So the whole goal for our group is to alleviate the triple threat, which is poverty, unemployment, and inequality. So today I'm here in my capacity as the chairperson of the Women in Physics in South Africa. And that my talk will follow this outline. I'm not going to go through everything here. So despite the remarkable strides that have been done over the past decades, women in physics and astronomy is still underrepresented. So I came across this statistical study called the Gender Disparity in Scientific Research. And actually what caught my attention was that they said that for women, it's like half of the women can be able to earn a PhD, and this shows that there is gender disparity in and it is more pronounced at higher academic and professional levels. It made me think of my journey in this science space. When I was in high school, there were a lot of girls in the class. We even had female teachers for maths and sciences. And then when I took my undergrad, we still quite a lot of girls. But as we moved on to higher levels, the numbers kept dropping. When I was doing my honor studies, we were actually 3 ladies in the class. So this is some serious concern. And another thing is that underrepresentation of women in physics and astronomy is not just a matter of numbers, but it shows the systematic issues and barriers that women face, which makes it limiting for them to fully participate in physics and astronomy and also progress in their researches. Well, talking about challenges, imagine now when women don't have role models that look like them in higher positions or even at a peer level. This is rather discouraging, and it can impact the decision that women take whether they should enter this space or even stay in it. And other unique barriers include implicit biases when it comes to hiring and promotion processes. Also, gender stereotypes. Also, gender stereotypes whereby women are seen as lacking the capabilities to be doing this science. Work-life balance challenges whereby the work environment sometimes is not conducive for women to actually excel in their professional and also personal lives, finding it difficult to strike the balance, and also lack of recognition for women contributions. And this can lead to fewer leadership opportunities for females in this field. Well, we all know that mentorship is very important in any aspect, in any career, but in a male-dominated field like our space, physics and astronomy, we really need that mentorship to be able to navigate these careers, because now women, they struggle to find mentors that they can relate to when it comes to their challenges. So that's one of the challenges that women are facing in this space. So to address those challenges, we have the Women in Physics in South Africa, which is a forum under the South African Institute of Physics. This forum was created to champion the cause of women in physics, to encourage girls and women to study physics, to encourage and support women to work in physics-related careers, and to assist in removing obstacles or overcoming barriers for girls and women. So there are some initiatives that WIPISA does to try and attract and retain women in physics. So we believe that the amplification of diverse voices and shared experiences is one of the initiatives whereby we have different people from different backgrounds where they share their experiences. This can lead to feeling of belonging and inclusion. And this is beyond gender perspectives, whereby the race of the person is important, the background is important. So those are the things that we look into, and we make sure that we all have inclusion and comprehensive representation of people from different walks of life. So as I mentioned, mentorship is very important. So the role of mentorship, advocacy, and collaborative environments is one of the important initiatives that WIPISA strives to. And we're also building supportive communities. So examples of WIPISA's activities include science outreaches, physics departmental lunches, webinars, mentorship programs, and role modeling. So it is very important to consider the interconnected identities. We're not just women, but we come from different backgrounds, like your religion, sexual orientation, the race, and all that. So this can pose special challenges in this field, but we need to address such challenges faced by different groups within physics and astronomy to ensure that everyone feels included and welcome. So I'm going to share with you some success stories of WIPISA and the challenges. So we engage in role modeling and representation, whereby we showcase or we try to make our physicists visible out there, where we celebrate their successes. And this is done by career profilings and celebrating achievements by these women in this field. We also engage in educational and outreach initiatives where we visit different schools from different regions in South Africa, where we go with our female physicists to try and inspire these young ones to be in the field of physics. Networking is very important. So one of our activities is to sponsor departmental lunches whereby universities or research councils, they send proposals to WIPISA for lunches whereby they get together with the women in the department and then they network and share their experiences. Physics advocacy is one of the activities that we do. This one is called Physics and I. So this is whereby we profile different women from different walks of life, those who've come to contact with physics or physics has shaped their careers in some way. So this is where we share their stories in a hope that it can inspire the next generation of women in physics. We also have webinars where we bring different people from different walks of life to share some growth opportunities and all of that. So we even have some come to share how to, like mentorship. We had one where we were discussing mentorship in the science space, and this was quite interesting webinar we had. So as we wrap up my talk, I'd like to recap some of the key points. Underrepresentation and barriers for women in physics, it's still there, but through WIPISA's mission is to increase female participation, provide mentorship, and foster inclusive networks. And we've had some successful initiatives, such as outreach programs, mentorship, webinars, and role modeling. So as a call to action, we can join WIPISA or become an ally of WIPISA, or you can offer mentorship to support emerging female physicists and astronomers, or support or participate in outreach programs to inspire the next generation. I would like to acknowledge the following parties, and thank you.
So let's thank Katikani for a lovely talk, Women in Physics. And now we have the last talk for our session. This is by Manisha Dua, and she'll be talking to us about the rise of women in astronomy in Nepal, a lilac revolution. You check that on this to see if that's working fine.
Hello? Is that
closer?
Okay?
Closer.
Okay. Is it okay?
Is it okay? Yeah, I think this is good.
Okay, please remind me, because when I start talking, I forget the time and everything. Good evening, everyone. I hope we all are as fresh as we were in the morning. So this is going to be the last presentation for today, and I hope you will be enjoying the things that we have been doing in Nepal. So slides, please. The time starts now. Okay, so I'm Manisha and I'm from Nepal, and I work with Nepal Astronomical Society. And if you do not know, Nepal is in Asia, and it is a very small country in between India and China. So as the size of the country, the number of population is also quite less. And out of that population, we have a very few number of people who are doing astronomy. So welcome to my presentation. So I have a dream, and I didn't realize until I was preparing something for the Women and Girls in Astronomy Month this year, for the year 2024, and Carolina come into my mind, and I wanted to dedicate a page of my journal to her, and then I realized there were so many things that she had been doing that I was trying to do. So actually I wanted to be someone for our girls to look up to, because when I was a child, I didn't have anyone whom I can share my interest and the things. So I made a very late start in my like astronomical journey, but like that is going so far, and I think everything happens for a good so I took like the lack of opportunity as an opportunity for the girls in Nepal. So like we have like different stereotype, and you know the first one is gender, and that happens everywhere, in which STEM education in particular is dedicated for gents only, and that was the challenge because of which I pursued bachelor's in physics, because like there were only 5 students among 120 students plus, and that is how like I started my astronomical journey henceforth. That was a challenge, and like we also have a different social hegemony, which generally like it questions on your character, because like I'm one of the very less, I think I'm the first astrophotographer in the country, even though like I haven't taken a lot of pictures, but I have few ones. And like since like during my astrophotography journey, I used to need to go in the dark, and I had to spend night at some dark places, and like there were always questions to me and my family, like why you are letting your daughter go and do this kind of things that is particularly like she's doing at night, and we do not know whom she goes out with. So like these are some of the social hegemony like that actually made me strong, I think. And like there are pressure of getting married, and I'm free of that pressure because my parents understand my passion. And generally physics and astronomy, like they are taken, engineering, STEM subject in particular are taken as a male subject. And like recently, like I started my PhD journey, and then I realized the domination that women feel in the, women feels like in the area of STEM field. So and we have this saying like we cannot dream, like girls cannot dream. So I have a dream to encourage every girl in the country to dream, and that's why like I'm here. I have been doing astronomy since more than a decade now. So since like I already mentioned that I have been working for more than a decade now, like these are few of the women like who are making contribution in the field of astronomy education, astronomy in the country through like different roles, you know, like and the pictures that I have kept in these slides, like they are in terms of the chronological order. So we had Miss Rupa Manandar as one of our first female headmaster from a public school who was the part of my astronomical journey. And why I feel this woman is strong was, and why I wanted her to be in the group was because we had one session at one school in 2015 where we have a lot of like male science teachers from the Kathmandu Valley, and she was the winner of one of the events that we did at that time, and like we had a good photo. And when the photo was posted online, she was cropped out of the photo. So so like that is something that I shared with her, and like she slowly understood, you know, like even though like you are doing something, you are contributing something, but you are not being appreciated. So similarly, we have Reja Thapa, Ekta, and Rabina. Rabina is very active these days. So we have like Dipti and Ankita who are like contributing in the field of astronomy, flourishing astronomy in the Nepal with all the relevant strength they have, like that academically, hands-on activities, or like as well through the teachers training program and so on. So I'll be talking short about like the projects that we have been doing in Nepal. So this is particularly the project that was supported by IAU OAD for the year 2022, but due to various reasons, like it just postponed it. During this project, like we went to 6 schools in 4 provinces in the country, and like we conducted workshops while forming astronomy clubs in the schools. And the best thing about this project was we had a wonderful number of girls participation, and as we in the proposal, I said like maybe we will have 50 to 50% ratio of male to female during this project, but like the female to male ratio was 54 to 40%, and like we were supposed to reach at least 1,200 students throughout the country, but like the number made it to 5,000 and plus. So when it comes to the female leadership, in case of authority and the club presidents, like all the role, 50% of these people were also women, and that was one of a very wonderful success story. And similarly, like we have this teachers training program, TTP, that is been supported by IAU OAE. And Robina, you see the one like who is delivering her talk. She was the one who actually got this grant, and like she initiated this project, and like this was actually designed to empower and equip science teacher through astronomy as one of the tool of STEM education. And like out of the 15 science teachers, like since the teachers has to do like what they learned during the training in their schools and respective area, and like we realized like most of the school from where like the teachers were female science teachers, they had this implementation very well in their schools as well. And as for the students students involvement, like we had, I'm just trying to give you some example through the World Space Week program and the Students Outreach program. So like World Space Week is an annual event that we do like every year, and like we have actually divided, we welcomed, like provincial coordinators from each of the places, and these students are like doing a wonderful job. So since we are working in case of low or no cost material, like you can see in the last picture, like the girls are enjoying the biscuits, and like that is the Oreo moon phase, where like they enjoy the session most because after completing their project, in the paper, they are allowed to eat the biscuits, and like they are quite happy. So so they even requested me that next time it should be momo. So momo is a Nepali delicacy everyone loves, and if you ever visited Nepal, I would recommend you to have momo, please. So yeah, also we also have this inclusive universe kind of program, and this is the other way around. This is why I'm using the word, the line other way around is generally like we have like the so-called normal people, like they are giving the sessions to those like who in need. But after our programs like SN and some programs that we do with the visually impaired people, now they are going back to the society, and they are actually giving trainings and the workshops to the normal the students without any disparities. So like this is also one of the wonderful outcome of the things of the workshops and the program that we have been doing. And so talking about the impacts, as you can see in the pictures, we have more number of women and girls in the picture, and some of the people who are there they had been very supportive to us in doing everything, and that is how like I would say like I'm here. So our program had led to in the development of confidence, and like this has definitely like encourage the leadership in the women in astronomy. And yes, like we are having a wonderful army like for the astronomy outreach, and this has actually brought a change in the perspective of society, because last time when I was traveling to the eastern part of Nepal, where we had the project at the deaf school, I had some of the parents of the deaf students come to me, and they said like they would like to continue their education in STEM field, particularly like they were going for the computer engineering kind of thing, which like they could do easily. So like this has brought up change in the perspective of the society, and you can see in the picture we have students age around 6 years old to 60 plus years old. So like this has strengthened the relationship between different generation. As for a result, now like there is a wider like programs in which like experience meets energy. And this also had brought a wonderful increase in the interest of the teachers in the field of astronomy. And we are, of course, like developing the human resources needed. And the government or provincial local bodies are interested in like, supporting our initiative. So even though like we have 7 provinces and I live in the province 3, which is the capital of the country, but province 1 has supported us with a small funding last year to run similar kind of project. And this year also like they are supporting with a small funding, which is like around 800 to $8,000 to $10,000, but like that is a big amount for us to bring an impact, and that had been bringing impact. So like these are the impacts, and looking forward, we would like to give the so we would like to, we are looking forward to like give the required recognition to these women, like who are women and girls, like who are contributing in the field of astronomy, and we would also like to support for their academic excellence. And I also personally I am also personally like looking for the required support to continue to help these girls and girls with the higher education they deserve. And so like since we are working on mentor concepts since long, we would like to optimize it more when it comes to like like gender, particularly the female. And we had actually like a good number of girls and women that we had been training and like giving the workshop that needed, but like we are unable to retain a good number. Yeah, so like we would like to create a workshop there who can think beyond themselves and contribute to the society. And next thing is like, since we are very small in number, our voice is not being heard. So we are trying to reach a critical mass so that like whatever, like, our voice can be heard by the government or the people who need to hear this. So we can build a wonderful environment for the women in astronomy in the country. So if you have any queries, I will be here until every one of you leave the room. And thank you so much for patience and listening to me.
Thanks so much, Manisha.
Thank you, Priya.
Thank you. Yeah, and first of all, I'd like to thank all our wonderful speakers for this session, for allowing me to, just go on. And I think the take-home message is there is an issue, and there are lots of efforts being taken by people. And, small efforts build on to a big thing. And I hope that all these efforts add on. So now, if for people who, since you all have all sat, in case anybody has burning questions for all our speakers, they're all here. You could ask your questions. I stopped you, sorry, earlier, but now we can have the questions. Yeah.
Hi, everyone. I'm Aparna Venkatesan from the University of San Francisco. The art was so beautiful for our, I'm not sure where, Nepali speaker. I'm curious who did the art in your talks, who did the art?
Thank you. Actually, I wanted to share that like at the end of my session. So during the Women and Girls in Astronomy Month, we had a session for every girls and woman like who are contributing. And we actually printed the picture, and like it was, did you realize like there were phases? So like then like we asked everyone to put the color of their choice, no matter what, and it ended with the last picture. Thank you.
Thank you so much. Congratulations on this great effort and your hard work and all good things. There was one more question. I promised to pass it on after this. I'm forgetting one of the earlier speakers had a map of the world, and it was a UNESCO report of the percent of women in physics. Yeah, thank you. But the data was missing for North America and Australia, and I was curious.
I was surprised the same as you are. So it is missing, yes, for Canada, for US as well. But I took it from the UN report, so Women in Science report. Why, I really don't know, yes. I think Australia was missing as well, which is also quite surprising, yes. Exactly.
Was it supposed to be developing world or something?
No, it's like the current picture in the whole, the Europe is there with all the gender imbalance, but in science, but I don't know why US is not represented, and I really don't know. We should ask, yeah. It's not my map, yeah.
Yeah.
Yes, it's not my map, yeah.
Yeah. Any more questions? Please, please. So that I don't feel guilty. Yeah.
Hi, thank you for this lovely session. My name is Mpati Ramatsogo from Rhodes University, South Africa. I have a question for a person who was talking about female-only positions in Australia. I'm sorry, I forgot your name. Hi. Often when I speak to the young student, they often worry that they got to where they are because of DEI. So to all the people who have received these positions, have you ever had a discussion with them to hear how they're feeling about their positions?
Yes, I have spoken to them. So at the time, we were only going to bring in one, and there was two such strong candidates that two were appointed at the time. They have definitely received, I guess, a little bit of backlash from it, but there's been also a lot of support and recognition for their actual expertise as well. So yes, that is a challenge. The other thing that we have is we bring in like so we have a lot of couples working as well, particularly when we're establishing ICRA. There was literally no one there, so we had to bring in a lot of people, and we did bring in, a lot of couples as well. So that's also been interesting as well, seeing what levels those different positions come in and the different genders and what their career progressions are.
Thank you. My name is Miriam Nyamai from Sareo, and I had a question for Brenda. You mentioned that for you to participate in the program, that you have to submit a proposal. Does it have to be specific, like the field you're working in, or is it determined by your hosts in the field that they're working in, so that you can have mentorship and all that?
So what you do is you will contact scientists from that institute. I'll give an example. In my case, I knew that I wanted to develop expertise in optical astronomy, and I have H1. So I had to I contacted Johan and Jesus, and together they helped me come up with a proposal that comprises of my skills and something that I want to get out of the fellowship. Yeah. So if you contact the people at the IAC, they will actually lead you to the people who think that you will get help with what you need.
Thank you.
Yeah.
Thank you so much. I have a question for our last speaker. So, can you just?
Yeah. Do you?
Hi. No, I'm here. Hi. I'm not Natalia. I'm from the US, but I'm kind of like when I heard you speaking, many things sounded very familiar, especially from the time when I was a child. So, my question to you is, what kind of obstacles in terms of from maybe family, maybe friends, society around them, do these girls experience when they are young and make their decision what they want to do? Because when I made my decision, I was just asked, why the heck do you want to do that? This is not what girls do. So I'm just curious what obstacles girls in this part of the world experience.
So when I was writing my thesis for my MPhil, that is Women in STEM Education, I realized like the story that I have faced is the similar for the girls, rest of the girls in Nepal. So the only thing that I didn't feel was like I didn't have the pressure of getting married, but the rest of the girls, they do have the pressure of getting married. And next thing was like, as I told you about the story of my astrophotography journey, like whenever you want to do something new and you want to contribute to something like that is not being celebrated by the people, you are always questioned, like you are doing it wrong. You know, for example, in my case, when I wanted to go for my physics, I had wonderful people who made a wonderful impacts in my life. They came to my parents, and I know like that was the best thing that they told to my parents, which was actually not for me. They said like, please ask her to go for nursing career. I respect nursing career, but like, you know, ask her to go for nursing career or banking career so that like she will get a doctor husband, or she will get, she will make a good money like while staying at home, you know. So I think like all the girls, like they got similar kind of pressures from the family and the friends. And once my friend, I remember one of my male friend, he said like, Manisha is going for taking pictures at night with so many people, so she might have fun. And like that means very bad in culturally in our case, you know. And after a few years, these guys, they said like, they were telling like, I want to make my daughter like Manisha. And I asked them, are you sure about this? You know, because your daughter will be facing the same problem and you will be having the similar kind of pressure in your head by rest of the people in your community. And they say, now we are quite clear. So like these are some of the things that like that is relevant to the other girls and women like who want to like have a different career field or do things differently. Do I answer you right? Yes. Thank you so much.
Now I have both of us. So, anything more? I hope all of you have the copy of the book. The book looks beautiful. It looks really nice, very colorful, very nice. And I found a lot of familiar faces in there. So thank you very much, everybody. Let's thank the speakers once again for... Oh, we have one more talk. Oh, sorry. I should have... Yeah, Joyful, you can read it out. Okay. Kenny, can you read the question online? Oh, we unmute her. Maybe she... Okay, please go ahead with your question.
Hi, can you hear me?
Yeah, we can.
Hi, everyone. I'm Sak Medina. It was very interesting talks and amazing to see how much work you have done in encouraging new generation, helping females in science. And I was before in the junior member meeting, and one of the topics that we discussed, it was like the reality that scientists, astronomers in particular, are facing with no permanent positions, with only less than 1% having a permanent position as a professor. So the other 99%, we are almost have to find different paths in science, different jobs. So my question is, how did we encourage more females in astronomy if we are not giving jobs in astronomy? So how we can go, or what is the plan of this commission, this female commission, to also have more females, but also guarantee a future of these females? So we are not thinking in the future that we are not having, that is the reality that we are facing right now. So it's not only females that they are not having permanent jobs. Of course, there are, if less than 1% of astronomers have it, and in the first statistics we saw, like there is almost no representation of female scientists in these permanent positions. So how we convince girls to go in this direction? I mean, I do a lot of outreach, and I love to share my passion about astronomy, but it's really hard to tell them there is no jobs, you know. Yeah. And now we are facing a reality that younger generations want to get paid jobs and work less. I don't know. So is there a strategy from your side?
Yeah, so thanks for that very important question. So in terms of the working group for women in astronomy, things have to basically be done at policy level, right? At policy levels, but then what happens is that people would have to do it, say, at institute level or at their national level, because at international level, it's not possible to make such policies. So I think in some countries, like Asha was telling us, in Australia, I'm even aware of it, that there are lots of policies which are in place, but there are many countries where these policies are not in place. So I think it's a difficult job, but like I said, it has to be done institutional level, national level, and I think we have some more people who want to contribute. One second.
Hi, my name is Sonia. I come from Chile. I have two comments. The first one, has anyone ever studied how men feel about the fact that forever they had an advantage? And is anyone asking that question? But then let's forget about that. The other thing is that we are focusing only on the fact that STEM leads to tenure positions, and that's wrong. You can do STEM in many ways, and what we are saying to girls is that they can do STEM, not that they can be tenure professors at universities. So I think it's a matter of our own limiting way of thinking that we think there are no jobs. For the moment, there are very few jobs as a tenure professor at a high-end university, but there are many other jobs in STEM.
Thanks a lot. Mariana has something to say.
Yes, I think also Mamta, I can see there, I think Mamta would like to comment something as well. But from my side, well, I think the question is very important, also very complex, no, in term, because there is no only one answer, no? And also it depends a lot where you are and where you go. And so I would say that when we speak about women in astronomy, as we could see here during the talks, it's not only saying, well, go to astronomy so that, and that will bring you to the permanent position, stability, and so on. I mean, through women in astronomy, there is on one side improving the conditions, using astronomy for empowering girls, not only to go and become astronomers necessarily, but it's really an important tool for empowering girls and women in general, wherever they are going to go later on, if they choose STEM fields or any other profession in their life. No? So I think there is a lot to be done in that aspect, using astronomy as a tool for empowering girls and women in general, and then bringing more women to science fields as well. When we come to the countries that are economically better standing, where we do have more people in science in general, it becomes much more challenging to actually get a permanent position because simply there are more people. In many countries across Africa where astronomy is just starting as a science field, actually that is still not really a reality, that it's much easier to get a permanent position just because still there are not many qualified people in the field. So most of the people that we are training, we don't have a problem in that they get permanent position. We have problem now, like in Ethiopia, for example, that we are lacking still women in astronomy, women in science, just because of all the difficulties that women are facing to come up to a PhD position. But basically, we are talking about training in MSc, in PhD, women that are already on permanent positions, but as lecturers, and that they still need to upgrade themselves, And that's the reality in many countries across Africa, So it really depends where you are and what the circumstances are. In any case, I think that the problem is very serious. Priya mentioned very important point regarding policies and strategies, and for whatever that we want to improve in terms of having more stability in future, we need a critical mass. So in any case, having more women that are there and men united and fighting for better conditions in science and more permanent positions and less precarious contracts is really important. So only in that way we really can achieve something. Yeah, that's a bit brief.
Thanks, Mariana. Thanks.
Yes, I would just like to say here that I totally agree with Marjan. I think whatever she said is correct. And after all the studies that we did, we understood that actually it lies in the hands of not only policymakers, but also the community. Both have to work. If the community is not participating into all those surveys that we are doing, and we don't have statistical data, we cannot really ask the policymakers to do anything. So it all really comes down now to participating in the surveys, collecting statistical data. Everyone can do it in their own countries, and then come up with better policies which can have equal representation for women and men. But your question is very important. And that's the question, that was the first question that I've been asking to myself and to all the mentors I came across, that if you don't have positions for women, and if women are facing so much of challenges and discrimination, well, then why do we encourage young girls to take up this career if they don't have a career as an astronomer? But we have many other careers, and I think women are needed in all STEM fields equally. We need to make them like and appreciate technical jobs, data analysis jobs, programming jobs, and not just stick to teaching and to just research, because they are equally well-paid jobs and they are equally highly demanding jobs, and you have better options. So the idea is not to diverge them to say, okay, you have no career, but you have to say that you get more and more skilled by using astronomy as a vehicle. For your PhD, you get more and more skilled, and you open up to better and more interesting jobs, and in more challenging environments like engineering, like technology, like data mining, like data science, and all sorts of positions.
Yeah, I'm totally agree. However, this situation is not particular of astronomy, it's particular of all science. So even if we encourage in STEM careers that is not astronomy, it's the same situation.
Yes.
So it's not something particular of astronomy.
Yes.
And I'm not criticizing the point. I'm totally agree, and I'm also working that in my community. But it's very important to work together with this issue, because if you go to statistics about satisfaction and happiness in young generation, the perspective of the expectations of jobs for the future is one of the main factors. So it doesn't matter how much we encourage, if there is no nice expectation of the future jobs for scientists. And now we see more online. There are more people quitting. There are more people online telling how toxic sometimes the system can be. So more people is disencouraged to be a scientist for this system. So it should be something that we work together, as you say, as a community, encouraging, but also pushing our own system to change for better conditions. Totally
Yes,
agree.
Yeah, I totally agree with you. And this is what we need to do. We need to work together, and
not forget it, because sometimes we are so comfortable in our positions that we are forgetting that more than a half of the researchers, people that graduate from a PhD, don't have this chance, don't have this privilege, right? I don't have it. So
I totally agree with you, and that's the point. The people who are representing these problems, they need to be very careful. They don't need to merge it towards other training and other kind of program. This is really about career in astronomy and career of women in astronomy. And if not in astronomy, then what better options they had. So that's the whole point, because they have worked hard to get their PhD and their postdocs. And why is their education and their caliber not being valued? That's the question over here. Otherwise, they could have just quitted and not done this kind of long studies under very underpaid conditions. That's the reality. But they did it. So that has to be valued, and why is it not being valued? That's where the whole problem is. And so our working group is focused exactly on that. And this is the reason why we are doing it. But let me tell you, this 3-year journey has been quite challenging, because we get threatening emails. Being very vocal about this has also brought us in a situation where we have got threatening messages and emails in my survey. So you also have to be together in order to explain people that you also get these problems on top of the fact that you are working for free for the community and trying to make it better. And all these problems are existing, and it won't work unless and until we come up with statistics in each and every country. We have to come up with statistics, put it on the IAU website, and provide it to the policymakers. That's the way it's going to work.
Yeah. So thanks. One final question. That's the final one. Yeah.
Sorry, I've already spoken. So did anybody else have a question?
I think it's okay. You finished.
Okay. And it wasn't a question. It was just backing people up. I teach in the US, and the students are really asking, what is the value of my education if I don't have a job at the end? If I'm going to take out loans, which is a big issue in the US, people are asking that. So I'm really backing up what you're saying. What is the value? Because I need employment at the end. I don't want to sink further into debt. And the other great point about how do we count those we retain, I just think in society, we already do so much invisible, uncompensated labor. I have learned so much at this conference about all the women doing amazing work outside of the ways I would think to count their presence. They're really out in the communities and doing important, extraordinary, sometimes compensated work. And I'm so grateful for them and also to know of them. So I'm just backing up your point, like how do we count those we retain? So thank you.
Yeah. So I'll once again thank everyone so much for being here. And we'll continue this conversation tomorrow. Please do attend the following sessions, which we have in the morning from 10:30 onwards. And see you tomorrow. Bye-bye.
Bye. Thank you very much, everybody.
Oh, thank you. Thank you so much. Of course. Isn't your photograph in there? Yes. I can these guys back. Hello. Oh, thank you so much.